Thank you, everyone, for those of you that are here and for the many of you that are online. And it is our pleasure to get started with the second edition of the Zeno user meeting, the Zoom 23, as we called it this year, and I think as we'll continue to call it in the year to come. So I'm Angelo Corsaro, the Zeno project lead and ZettaScale CEO and CTO, and I will go through the agenda real quickly, and then we'll take 15 minutes to do 1 year retrospective to try to understand what has happened in this one year. So besides the opening remarks that we'll try to keep short because we have an agenda packed with presentation, we have 10 users that will be presenting today their use cases on Zeno, some of which are here. Thank you for having taken and made the effort. Some of which have shared the video. So that's the case of Hideki because he's in Japan. It will be very late for him. But don't worry because next week you'll have a chance to see him live at the user meeting in Tokyo. So after the opening remarks, 1 year retrospective, 10 contribution from very interesting end user. So we'll kick off with Samuel from Flex, a use case in industrial automation, to move then to Rodrigo from The Construct, which is one of the leading ROS2 educational companies and R&D companies in Europe, which will share his experience with Zeno, to move then to NXP and precisely Peter van der Perk, again, super interesting use case on drones, Sarah Gallian, which will be telling a little bit about the software-defined vehicle initiative in Eclipse and the role that Zeno is playing in context. Then a super interesting use case from Felix. We learned recently about their use case. Their CTO visited our office 2 weeks ago, I believe. It's super cool robotics use case. I think everyone will be enchanted by this, and I'm pleased that they accepted to present at our user meeting. Then Franco Cipollone and Yadu will be telling a little bit the experience on Zeno as a ROS2 RMW alternate. And Stephen Arley from General Motors will be discussing about the integration that are taking place between U protocol, GMU protocol, and Zeno. Then we will have Elias, which is here sitting with us, telling a little bit about the use case of tractonomy, why they use Zeno, and what is their use case. Hideki Takase will, delighting us with some longevity Elixir. Okay, so he brought Elixir to Zeno, and we'll learn a little bit more what it means, how it looks like, and why this is some pretty exciting news, and in which context they are using Elixir in some robotics research at the University of Tokyo. And we'll conclude with Christopher Elpa from TT Tech Auto that will be showing some interesting results of a collaboration with our R&D team on data flow programming for automotive using ZenoFlow, some of which some of you will recall perhaps. We've had a presentation on ZenoFlow also at the last user meeting. Then the ball will be back on the Zeno team camp, and we'll tell you what we're planning as next feature. We'll do some QA, and for those of you that are here, or those of you that still have the time to join, there will be food, drinks, and we'll be here around up to when we will have energy. Okay, so let's start with 1 year of Zeno. What has happened, and where are we going? So looking back, first things that I would like to recall is that one of the things that we did very early on in 2023 was to give kind of a personality, a face, and a visual to our dragon. I think it always was alive in our mind, right? But we tried to make it alive for all of you, and that was the first cartoon that we posted, introducing the series of cartoons and comics that we release every single month or anytime there is something special, where we use some kind of, I would say, Socratic dialogue between the dragon and a robot, or perhaps the dragon and some other of his friends, one of which is our other product, Cyclone, either to tell interesting news or to kind of give away some concept around the protocol itself. So I guess all of you are, getting now accustomed to us communicating through comics. And that was indeed one of the things that we did in 2023, which is give the Blue Dragon protocol actually a proper face, a character, and make it alive. Which I think it's always better, because middleware is like the nervous system; it's invisible, and it's easier when you have a way of visualizing what you do, and if it is in a kind of a smart way, even better. But let's move away for a moment, just for a moment, from comics, and let's talk about feature. So this year we released a pretty impressive set of feature, and I'm going to go only through the key one, okay? So they are more or less, I would say, in chronological order, but not always. So we had already support for TLS in 2022, but this year we extended that with support for mutual TLS, so MTLS, and support for using the Let's Encrypt framework. We expanded plugins, and one of the plugins that actually we added around June was the MQTT plugin. This is an important one because MQTT is a very common protocol. As we know, it has severe topological constraint, right? And what our plugin allows you to do is to deploy an MQTT plugin essentially wherever you want, and then route in between them through Zeno, as illustrated in this slide. Something else that we added was a feature that we wanted to put in for quite some time, which was the ability to have payload or in query. So Zeno query, typically you would add payload or argument as part of the query expression. You could put everything, but that would mean you want to put an image, you have to, in some cases, base64 encode it, which is not very, very convenient. And so we made it possible now, whenever you issue a query, you can attach an arbitrary payload, and that will be available to the entity that executes the query. Obviously, some of the user, and I'll get back to that, were waiting for this feature, which again makes some use cases even more efficient than how they were before. We added support for S3 and Minio, so now you can store data on Amazon if you're using Amazon S3, or potentially you can use Minio as a self-host solution, and in a progress or in a process to move toward Automotive, we started making Zenopico compliant with MISRA C, okay? And more to that in a couple of slides. We added finally C++ APIs. Okay, so Zeno, the core of Zeno is written in Rust. Historically, our API were mostly Rust, Python. Those were the first two API that we had. And then we had C, and now we have support for C++. C++ API that allow you to target just as compile switch or compile option, both the full-blown Zeno as well as Zenopico. We added API to detect connectivity status, which is also quite important when you need to perform differently or different action based on the fact that you are connected or not to the network or to a router or whatever. Based on the request that we had received at the ROS conference, we had made a ROS1 plugin. So the ROS1 plugin allows now to route ROS1 traffic on Zeno. Julian will be giving a little bit more details on this plugin and how also it relates to the ROS2 plugin. And another feature that was introduced was transport whitelisting. In Zeno, recall that we can sit as low as the data link, and we support plenty transport. You can run on serial, you can run on potentially Bluetooth, you can run on shared memory, Unix socket, web socket, TCP IP, QUIC, you name it. And this feature allows you to decide the set of transports that a runtime is supposed to use or can use. Another super important addition was the support for liveliness and liveliness token. So this is an important feature because it allows you to assert liveliness of entities across a network, and it has built-in support on the protocol. So this can, if you implement this at application level, can usually start generating or causing the generation of lots of traffic. What we wanted to make sure is that we could provide some abstraction for you to detect liveliness of application, perhaps building group management protocols, while at the same time ensuring that you have scalability. Because we have some special logic in our protocol. So that has been added. As you will see, this is one of the key elements that is used within the ROS2 plugin and will be used as part of the ROS2 RMW for Zeno, and I think was a pretty important addition in 2023. Again, look our blogs or take a look at the RFC to learn more about it. But that's quite powerful mechanism, powerful and scalable. Then there were quite a few protocol extensions, and as you have noticed, in the latest release that was Dragonite, we introduced some wiring compatible changes. Don't worry, because we are going to introduce another series of wiring compatible changes in the next release, and then we promise we'll be done. I mean, so far we try to live to our promises, right? At some point we said, guys, we'll stabilize the API, and we made sure that our API is now entirely built around the builder pattern, so that gives us the ability to change, to expand, extend the API without breaking backward compatibility. Now, we didn't want to freeze our protocol, because the number of use cases was changing and expanding. We were learning more about use cases that perhaps we had not necessarily thought when we started the protocol. And so there were some new features that we wanted to put in. And we think that now we are in a position where, based on the current user base, with the next batch of a protocol extension, we'll be able, as we'll discuss later, and Luca will discuss later, to stabilize, call the protocol 1.0 and guarantee backward compatibility, as we did for the API essentially earlier this year or late 2022. I can't even recall anymore. But besides the stabilization of the protocol, and as we will see, the version 1.0, so the graduation into version 1.0 of Zeno protocol, in Dragonite we had several improvements, notably support for multicast, and some additional optimization for constrained devices. We also rebuilt the Rust plugin. So the Wireshark plugin, the original plugin was built in Lua and was having serious performance utilization under heavy workloads. The new plugin is built on Rust and is based on the exact code base of the protocol. So any changes on the protocol is reflected immediately on the Wireshark. So there is no potential for bifurcation. We introduced API for Kotlin, which opens the door to the use of Zeno in Android. And you can already find in our repository some example of a client application or UI application for Android using Zeno with the Kotlin API. Other addition that was done was an ultra latency transport that goes hand in hand with some shared memory links that further reduce Zeno latency. ROS2 plugin, so that was another important addition. Again, Julian will describe the detail of this, but this further improves our usability and performance by quite a bit of the DDS plugin. So we had built a DDS plugin that wasn't specific to ROS2. This ROS2 plugin leverages all the semantics that we can assume in a ROS2 system that uses Zeno, that uses DDS as an RMW. The performance are far better than the DDS plugin, and the support for actions as well as the support for rows graph and introspection, as Julian will demonstrate, are just incredible in this plugin. We released the Zetta platform. So this is our PaaS offering from ZettaScale that allows you to automatically and in just a matter of a few clicks provision a Zen infrastructure that spans from your favorite cloud provider down to your device. Okay, more later we'll have some demonstration. Now, if we move away from features, what has happened on the market? So let's start with robotics. So this year, I think, was the year in which Zeno really witnessed an incredible adoption in robotics. So we have now quite a few commercial deployment of Zeno in R2X. And that's just because it was making it much easier to operate robots, or possible to operate robots that, across wireless network. Again, we have heard from some users story like, I was booting up my robots over a wireless using ROS off-the-shelf RMW, couldn't communicate, right? Whichever is the default RMW. Then using the DDS plugin, and that works. And if you move to the ROS2 plugin, that will be even better, as I said, as we will demonstrate later. But in any case, I think that as we will see, the word has spread. Our user found that Zeno was bringing important value in this domain, and that's perhaps the domain where we've had already had an advantage in terms of adoption, but that has grown more than any other domain this year. Other incredible things, and you see the dragon celebrating, right, going completely crazy around this. His dream come true. Zeno was selected after a very thorough study as the RMW alternate. So again, there is a report. We'll provide, maybe guys, you can post on the chat the link to the report, but there is a report that has been created by the ROS2 working group and Intrinsic, analyzing the requirements of robotics application, looking essentially at the bulk of the protocol available. And Zeno was the protocol that ranked as the best choice for robotics in 2023, which is incredible. I mean, we are very proud of that. And as you will see, we are very, very happy to support this endeavor, and supporting already the ROS ecosystem and Intrinsics building this RMW. In automotive, a few things happened also. The tail of 2022, but this happened between the last user meeting and this user meeting, so I'll still consider in the last year. The ITUT selected Zeno after a 2-year study as the protocol to be standardized for intelligent transport system communication. Read the report, it's quite interesting. 2 years long project that looked at all the protocols, and there was one use case that they couldn't solve, that of the digital witness. Okay, and once again, easy to solve in Zeno by means of distributed queries. ZettaScale got ranked as one of the startup to watch in 2023 because of Zeno. And we were identified as a key technology provider by this analyst firm in vehicle-to-anything communication, or vehicle-to-everything communication. So once again, interesting, because in a domain, right, where we start to make our first steps, we already get some recognition. And I think it's quite normal, because we've seen a cross-contamination from robotics to automotive, and that cross-contamination is happening faster and faster. And so it will be, perhaps that will further accelerate the adoption of Zeno in automotive, which is already, as we will see, happening. Talking about that, we will learn a little bit more in Sarah's presentation, but the role of Zeno in automotive and the relevance of Zeno in automotive has also been recognized by the SDV, the Eclipse Software Defined Vehicle, which is an initiative, a pretty impressive initiative, organized by Eclipse, with participants like Covesa, General Motors, Bosch, and so on and so forth, trying to develop an open source infrastructure for software-defined vehicle. Zeno has been selected as one of the communication middleware in addition to MQTT. And as you can imagine, MQTT has been there forever. Today is used quite a bit for R2X. I mean, there are some challenges today that that are well known with respect to support for high throughput or even topologies. But for sure, MQTT cannot address the requirement of the on-vehicle communication. And that's, as we will see, the first target where Zeno is being looked at. As such, Eclipse U protocol, so U protocol was a protocol contributed by General Motors to Eclipse, decided to implement a binding to Zeno as the first protocol bind to a U protocol. And Stephen will be telling a little bit more about this in his presentation. To finish up with Automotive, AutoSAR Classic now also has support for Zeno. We added support, and in fact, we've integrated Zeno Pico in MicroSAR, which is vector AutoSAR Classic implementation, and we are going for ACLD certification. Okay, so in that respect, if you want to have a car that runs on Zeno, right, will soon be possible, not just because of the integration, but also because of the certification. What is happening in other verticals? Well, I mean, Zeno is being adopted widely across verticals. We have, and we learn almost daily, right? Because being open source, we can't easily keep track of who is using. And by the way, it's always good to let us know when you're a user because, it gives us lots of pleasure, let's say. But I mean, a couple of days ago, we found out by accident, right, Gabriele, that we are being used by a blockchain. I can't recall the name. Bytewire, yes. And we found out by accident. So kudos, guys, on that. So they focus on performance. There are some pretty impressive comments on our Discord because, they care about performance. And they were mentioning that Zeno was even too fast. They had to slow down some part of their infrastructure. Otherwise, certain things weren't working as expected on their side anymore. Anyway, so we have application interscale analytics platforms in blockchains, industrial automation, and we will see, for instance, the first presentation is precisely on industrial automation and counting. Okay, so the momentum is growing, which is great. And just to pinpoint one of the reasons of this adoption, especially on large-scale application or application that requires integration of very heterogeneous environment, is perhaps this article that was written by Amazon early in 2023 that compares the key established protocol, so MQTT, AMQP, DDS, and COPE, and looks after all the limitations that this protocol have to address IoT application, and then concludes, well, perhaps Zeno is the way to go for the kind of system that we're trying to build. And this is actually what we are seeing. So exciting times for our Blue Dragon protocol. All of this obviously wouldn't be possible without the team. And compared to last year, the team has grown quite a bit. So this is part of the team, not all the team. Some of the people were not here because either they are sick, unfortunately, so recover soon, or for other reasons. But let's say that's the bulk of the team. And a team that continues to grow, and I think a team that keeps quite motivated, and they are all here. So we took this picture right before starting the stream, so it's really hot from the press. And so the question is, what's next? But okay, so we are in Paris with the user meeting, we are going to Japan, and the dragon can fly, so the sky isn't even the limit. But jokes apart, we'll see a little bit what's next in terms of feature in Luca's presentation later on. And at this point, what we'll do is to just give me a couple of minutes, a few tenths of seconds to start coordinating with the speaker and start with the end user presentations. Hello, Sam. Can you hear me?
Hi, Angelo. Great. Yes, I can hear you.
Great. And we are live, so we are streaming. So, by the way, can you actually share your screen? So I will change the is around because that was looking kind of weird. So if you can share your screen.
Yes, here it comes.
Okay, great. Perfect. Look, I will hide myself because you don't need to see me for the time being. But before hiding myself, quick intro, and then you'll be able to go. Okay. So Sam is CEO at Flex. Flex is one of the actually brave early adopter of Zeno. They also wrote a very interesting white paper justifying or explaining, their selection process. And we always look into performance, latency, throughput. But I think the comment that I liked the most in your white paper was the one on R&D team size, and the fact that besides the performance, it was the easiest to do, the easiest to use, and the one that you felt right. Even a small R&D team could be successful with. Okay, without further ado, Sam, the stage is yours. I'll eclipse myself, but I'll remain here looking at your presentation, and I'll be back once you're done. So, best of luck.
Yeah, thanks, Angelo. Thanks for the nice introduction. And before I joined this stream here, I was watching it on YouTube, and I can 100% agree with the quote of Amazon, because this was also one of our findings when we did the white paper, and I come to this later on. But first of all, a few words about myself. I'm one of the founders of Flex. What we do at Flex, I'll explain a couple of minutes later. I'm in the industrial automation now for more than 10 years. I was starting as a software engineer. I was a product manager for quite a time. And now since almost 3 years, I'm doing Flex with 2 other founders. The company also grew a little bit since then. Yeah, and now let's jump into what we do here at Flex. So I know that this might be a very international audience, but maybe someone of you has ever seen one of those slides here, one of those logos here. If not, the first one is Schneider. That's a German-based, or was a German-based company. The second and third, I think they were UK companies, and all of them, they were world leaders in the development and manufacture of PCs in the 80s and then early 90s. The question is why maybe you don't know those logos anymore, and we discover this now a little bit deeper with the dilemma of the PC manufacturers in the 80s. Everyone developed their own side, or controlled everything themselves, from chips at the bottom to sale at the very top. And now really the question is why they no longer around today. Because they were doomed by the silos they have built by themselves. Because with the advent of standard hardware and software, developing everything in-house was much more expensive and no longer economical. So there was a consolidation of the market that caused many of these companies to go out of business. I think one of the only companies which survived this was IBM. They managed to do pretty good. They're still existent and they're still running a very huge business. But at the same time, new companies arise like Dell, HP, Toshiba, and you name it, all the big PC manufacturers. So another type of computers are the PLCs, and now we are in the area of industrial automation. These are computers for the control of machines. And here we are in the middle of a comparable consolidation. So in terms of chips, the manufacturers are focusing on ARM and Intel chips. And in terms of operating systems, more and more are using Linux. Most industrial apps are already prepared for this today. And there is currently no uniform channel for sales and distribution. So people are still working in silos here. And this puts many, many companies in existential distress. And that's where Flex comes in. With Flex, we offer the fastest growing and so far only independent app marketplace for the industrial automation industry. Now the question is, why now? Because we see that the consolidation is slowly moving from the bottom to the top. And there is a growing understanding of the need for a unified marketplace. Large players can afford such a development themselves, while smaller companies fall by the wayside. For them, connecting to the marketplaces of the big ones is usually out of the question for competitive reasons. Yeah, you would never be a customer at your competitor. And that's why no other industrial marketplace is growing as fast as Flex. Yep, and with our marketplace, we bring the industry apps to the PLC with one click. You see a screenshot here on the right side, and keep them up to date there. And what's in for you as a PLC manufacturer? So first of all, you have your customized automation solution. So that means that you deliver your PLC, your IPC edge device, or even virtual machine with your version of Flex, and provide each customer with a unique automation solution that they can easily extend themselves. And this is now also one of the reasons why together with Zeno, Flex and Zeno are working so good together, because everything that we develop that runs on the devices is also open source. So here we have I would say, a very similar mindset to what Angelo and his team are doing. Second thing is that, of course, we run the marketplace, but you can, as a PLC manufacturer or even as a machine builder, have your own branch marketplace. That means to the customer, you have your branding, you have your logo in front. You can decide which apps are installable on your devices, which not, and you can even offer apps that are exclusively available for your devices here, and you get a full-fledged modern e-commerce platform, including licensing model and subscription model with that. Third one, and now we are getting a little bit closer to what Zeno does in all of that, is that this solution is very suitable for data management and retrofit. So not every time you have an industrial automation task, you are in a, let's say, greenfield environment. Usually, or very often, we are working in brownfield. So that means we have old devices, old PLCs that needs to be connected. And with Flex, this is totally possible with our service mesh, and I come to this in 1 or 2 slides later. That is some kind of the data and communication backbone of what we do here. Yep, and in terms of vulnerability and open source scanning, if you have problems tracking the software on your devices, then we are glad to help you doing that, to keep you up to date on vulnerabilities of your system and the apps you have installed, so that you know at any time if there are any security issues on your systems or not, and what to do to get around that. One example of a customer is the Baumüller Nürnberg GmbH. So this is actually a PLC manufacturer who uses Flex inside their controllers. Here you see the BMax PLC on the right side. And then Baumüller has many years of very deep experience in motion control and PLC application in the automation industry. And the solution you see here on the right side included a self-built IEC 61131 programming system. So for those of you who are not familiar with industrial automation at all, this is the programming language you use to program a machine. It doesn't have a very cool name, like, I don't know, TypeScript or Rust or so. It's very, very uncool name. But the problem of that one was they could not share the motion data with any other application. And with Flex, the Baumula users can now use all motion control data through Zeno in real time with all other apps from the Flex marketplace. Baumula thus offers its customers an open, flexible, and really future-proof solution with the highest performance and safety standards. Now it gets a little bit more technical, and now you see where Flex and Zeno work together with each other. So the yellow box is the device you saw in the previous slide. There our open source software stack is running, and this exists of, let's say, 3 layers. The top layer is a web application. That means a very easy to use UI that the user accesses to control Flex. The second layer is the application layer. That layer is responsible to install the industrial apps, to update them, to manage and monitor them, and also Flex itself. And the base layer here is, we call that Flex Flunder, which is Zeno wrapped in an additional library with additional interfaces that we implemented to it. And this is really the communication backbone between the ISE runtime. So here the motion control actually happens. This can be very fast, like below 1 millisecond. And besides that, we have, for example, HMI apps or databases deployed. Sorry. HMI apps are usually those apps that are running on a display next to the machine where you can control the machine itself. You can see how the machine acts. You can change the production and yeah, control it. And all this data is communicated in real time through Zeno here and can be accessed either by a specific lib. We have example implementations in C and C++, or can be used with any other connector like MQTT or OPC UA. So this is how it looks inside this box. And now the question is, how did we decide for Zeno? And I think this is now more than 1 year ago, maybe 1.5 or even 2 years. So we were working with a very, very early version of Zeno. And then we compared it to other communication layers like MQTT, OPC UA, and yeah, Angelo named them up front. What we were searching for is a layer that was, first of all, easy to use and real-time capable. And for that, we did some performance measurements on throughput, latency, bandwidth, and we compared it with the other protocols, and we compared also the usability. We also we had several things that we compared with each other, but in the first line we compared the real-time capabilities, and what you see here is the measurements with Zeno 060. Well, Angelo, you can correct me, but I think this version is now more than a year old. So this is really not the latest version that we tested there. And then our version 1.5 is also more than a year old. But those were the measurements we did. Do you have, sorry, do you know when version 0.60 was?
So I think that was early 2022 or something like that. Yeah. And I think that was even before, because 07 we stabilized the API.
Mm-hmm. Yeah, this was before. Yeah, that was before.
Yeah.
But you can see here the throughput, it was immense. We measured more than 1 million messages per second with small message sizes up to, I think it was 512 bytes. And then in industrial automation, usually the messages are not too big. They're most of the time very small, but you have a lot of them. So this is really important to have a high throughput on that stage. And on latency side, it was also very interesting to measure latencies between 31 microsecond and 55 microseconds, I remember. And a couple of weeks ago, I saw that, was it an American university that also did some measurements, Angelo?
So there is NTU, which is National Taiwan University, is top university in Taiwan. Made
It was
question of maybe you guys can post on social the link to the blog. So they did a paper. There is a scientific publication. They contributed a blog where they evaluated performance of Zeno, DDS, Kafka, and MQTT. And
exactly. And I just cross-read their findings, and I think they are very realistic, because what we did there 1.5 years ago was with earlier version, and we did not optimize anything. We just took it as it was and let it run. And I assume that they did some improvements, something to make it run even faster. And I totally agree that this is.
So in their case, no, I think it was off-the-shelf configuration. They just had very fast network, right? It was run on 100 gigabit network. That's the throughput. I think the hardware and the network, it's far, it's more enterprise than embedded than what you would find in industrial. But I think it's important to show that we can perform in both environments. And that's one of the goals of Zeno, right? To be able to run well in high-end hardware and networks, as well as on constrained systems.
Absolutely. So I was very happy, because we did not measure with Kafka, but we compared to DDS and then the other protocols, and they had more or less the same findings. And you can see how Zeno itself improved. Of course, they used a better network in that case, but I'm pretty sure that when we do the same measurements with the latest version, that it will even have improved here. If someone is interested in the white paper, send me a message or ask Angelo to forward the request to me, and I will be very happy to provide this white paper to any one of you. Yeah, and here we have a quote from Jürgen. He's product manager at Baumel. He's responsible for this yellow box. And as you can see, he's very happy with what we are doing here. And he said, being able to exchange the motion data between their system and all the other apps, this is really a USP that they can offer with us, and they don't see with any other system out on the market yet. Yeah, well, here's some references from companies we are currently working with. Some of them are customers, some of them are partners. And now, last night, what results did we achieve? As you can, of course, see, updating an automation system is much faster with Flex, because you just have to click on update and then it will work, and you don't have to use any SSH stuff and things that machine builders usually cannot handle. Of course, the savings are also quite a lot, because when you save time, you also save money. And for the PLC manufacturers themselves, we help them to deliver their PLCs, their new PLCs, 5 times faster than they did before. There's a special program, we call that Flexcelerator. That's a 6-week program where we together with a POC manufacturer, develop a first proof of concept, and after that, everything is up and running. And usually they want to see the real-time performance of Zenoh. They want to see how they can add their own apps and stuff. Yeah, and this is really the fast track for them. One of the benefits if you're working as a big company with a small startup like us. Yeah, and that's it. I said, my name is Sam. If you have any questions, put them in the chat, and I'll be happy to answer them.
Thank you, Sam. Thank you for your presentation. And so, as mentioned, so we'll thank. We can thank you. So, of course, put your question on the chat. And by the way, look at the chat because we are streaming live on Twitter, LinkedIn, and YouTube. So there will be potentially questions coming on from multiple medias, and you'll be able to answer any of those social medias, as well as on our Discord. So hang on a moment. Let me bring on Rodrigo. Rodrigo, hello. How are you? So
I'm good, thank you. Can you hear me?
Yeah, very well. So Sam, thank you. I'll just remove you from the stream, but
Bye.
Yeah, you hang around. Thank you again. Bye. Okay, Rodrigo. So you are good to go. We are so far perfectly on time. So as I mentioned in my intro, you come from the construct. The construct plays a key role in both education in the ROS toward as well as R&D and consulting. So as I share your screen, introduce yourself to our audience, and best of luck with your presentation.
Thank you. Thank you. Yes, I will make this slide presentation. Okay. So, hello, everyone. My name is Rodrigo Gonzalez. I am the head of robotics at The Construct. And a little background on myself. I am from Mexico. I live in Barcelona. And I studied mechanical engineering at Boston University. And I have a robotics master's degree from the UPC, Barcelona Polytechnic University. I want to thank you, Angelo Corsaro, and Julian Enoch, and Daniela Anastase for inviting me to speak at Zeno's yearly user meeting, as well as for the excellent support that you guys always provide through both Zeno's Discord server and also direct communications overall. So today I'm going to talk about our journey with Zeno at the construct. More specifically, how we use Zeno in our products in order to ensure fast and lightweight connectivity for all our robots. So what do we do at the construct? So we are the largest online robotics academy in the world, and we provide tools and resources for learning and developing robotic skills and programming. We also offer online and in-person intensive trainings for autonomous navigation, manipulation, fleet management, etc. And as the head of robotics in the construct, I am in charge of developing and maintaining cloud-enabled solutions for our students to practice and develop their algorithms in real robots. So our students practice in real-life scenarios connected to our remote robot labs, which you can see in this video here in the images, through our platform. And ROS2 is our main focus, as with most open source robotics development today. And let me show you a video from our robot cafeteria, which uses Zeno and is my example today. It's a short 3-minute video. So there you go. That's a basic overview of our Starbucks coffee. We call the cafeteria. This is enabled by Open RMF Fleet Management. This is created by Open Robotics. And so as you saw, there's a lot of robots in play here. So coordination between all robots is required and expected. So let me direct your attention to the diagram here on the right, which represents the communication flow between the student, which will be at his or her laptop, to our real robots in our office. So our student connects to our cloud platform, where they develop their projects and launch OpenRMF and basically any other program they want. And then that goes to our real robots in the cafeteria. However, this can be done with a single robot with a default off-the-shelf humble ROS2 humble DDS configuration. However, with more than one robot, especially as you expand, the default DDS implementation, the setup off the shelf with ROS2 humble is impossible. It's just very, very hard to make it to work and have every robot discover each other robot easily and quick and reliably. And Zeno provides the solution for this problem. So let me talk about the issues we encountered before implementing Zeno. So issues before Zeno. I first want to mention the main problem that happens with a default multicast DDS discovery setup. So on the right here, you can see an image of a router traffic monitor or router with a huge spike on the right, a blue spike of traffic that happens when we launch all the nodes that are needed for this system to work. So that's a huge number. That's like 2 gigabytes per second, which of course causes everything to crash down and connections to drop everywhere. And so it's a huge problem. And so we want to be able to limit this. And another issue is that DDS communication can cause problems in limited hardware. So things like CPU usage at 100% can happen if the discovery is too high, like it's trying to discover every single participant in the system. And usually software validation occurs in really nice, powerful robots or simulation. But in this case, it's so issues like extreme CPU usage or things like that on a robot are often hidden beneath the surface. So the combination of these two main problems leads to a slow response, crash prone, and robots that just do not respond as they are expected to. Of course, the higher the number of ROS2 nodes you run, the worse it gets because they need to be discoverable. And we can limit this with a custom DDS XML configuration, but it is not enough. ROS2 manufacturers, ROS2 robot manufacturers might not include this option, which was the case in the beginning for our setup, and can break the chain of information flow. So this was not enough to solve our slow and problem here. So this is the solution, a diagram of the solution we implemented with Zeno. So as you can see here, it consists of a main server at the top with the robots connected to that main server. And this is scalable, so that's why you see robot 1, robot 2, robot 3, all the way up to robot N. So the way we did this is running a Zeno router and a Zeno DDS plugin in each of these agents, each robot and the main server. And we can specify the endpoint connections for each robot to go to the server, and the main server to listen to all the endpoints to be able to communicate. Another thing that I want to mention that really helped our hardware limitation that I talked about in our previous slide is the ability to separate our robots in different ROS domain IDs. So you can see how the main server has a ROS domain ID of 0, robot 1 of 1, and so on. So this is especially helpful for things like hardware limitations. You can see here that robots are actually attached to a great robot, an iRobot Create 3, which is the base of our robots that bring the coffee around that you saw in the video. And this was the problem of the CPU usage that we had, and being able to separate the ROS domain IDs allows us to isolate that robot in order for the Create 3 to only see what's coming from the robot, which is basically a Raspberry Pi or a simple computer like that. So that way, you're not getting all the information from all the other robots or the main server that might affect the performance of the Create 3, this base, which is basically a black box for us. And so a combination of those two elements is what helped us solve this problem. And again, this is scalable, so you don't have to worry about the amount of robots added to the system. I guess in this scenario, until you run out of ROS domain IDs, but we haven't reached that point, so I guess we'll cross that bridge when we have to. And yes, something that is not pictured here, but it's also very helpful, is the topic control flow that you can specify in the Zeno DDS plugin. For example, the robot might care about the sensor information, for example, the LiDAR information or the odometry information within that subsystem. But in reality, the main server does not care about all that info from the robot. So you can just allow certain topics to go through with Zeno DDS plugin. And for example, the main server only needs to call action servers running in the robots in order to control them. So, and maybe the battery level, things like that. So this, what I call the topic control, you decide what can go through and what can't, is also another element from Zeno that we use that practically solved all problems. So yes, that is basically our solution. Very simple, just running a router and a DDS plugin in all our agents and separating in different domain IDs in order to ensure that no DDS data is sort of leaving the robot and interfering with the communications that might lead to the multicast or problems with the network that might arise. I'm not a networking expert, but this is exactly what I'm looking for a solution, is to just run a couple of things that make the middleware invisible, so I won't have to worry about it. So after this solution, we can take a look at our issues after Zeno, which are none. The communication flow that we had in the earlier diagram in the challenge we face is now complete. So the student at their laptop can connect to our platform and then connect to our real robots, all with the help of Zeno. And there are no issues with communications, no drops of messages, nothing like that. So that is a great solution implemented. And then I want to say a couple of takeaways for this presentation is that, in my experience, Zeno provides the best solution to connect multiple ROS2 robots. I was listening to Angelo talk about, the off-the-shelf, how it works, ROS2, what do you expect to happen versus what actually happens. And of course, there are many ways you can solve this, but I think Zeno provides the quickest and best solution available. Another thing that I really like is that Zeno can be used even in the simplest robots. So in this case, a Raspberry Pi, or even smaller. I'm sure a Raspberry Zero, one of those can work with the communication, and it prevents these CPU usage of a smaller hardware limitations that you encounter in the real world, which is what we're looking for. And this extra layer that allows with your DDS plugin, that allows control of the domain separation, so you can ensure nothing's going out that you don't need, as well as selecting specific topics you want to bridge over the network, can help a lot, especially when you start thinking about things like heavy ROS2 messages in topics like point cloud messages. I know this is a huge problem to wirely transport through the normal default ROS2 setup, and Zeno solves that really well. And yes, that is basically all I had to say about my presentation. I hope you liked it, and I'm ready to take any questions you might have.
Thank you very much, Rodrigo. That was very nice presentation.
Thank you.
So, well, question. Yeah, thank you. I hope you can hear it's here. And well, many virtual clap from the community, because the bulk of the people are watching online. So question will be posted on social media. So please keep an eye on the chat, and
Okay.
we'll answer a question. We'll answer a question that way. So that said, let me bring on Peter. So let me just do this. So Peter, here we are. Hello, Peter. How are you?
Hello, good.
So great to have you on. So Rodrigo, once again, thank you very much. Great presentation, and I'll now phase you out.
Thank you.
A quick, and yeah, thank you very much. Okay, so Peter, once again, thank you for being here at the Zoom 2023. Very much looking forward to your presentation because I missed it at Ross because I was too busy at the booth, and they told me it was quite incredible. So I didn't look any recording because I wanted to listen it from you live. So you work at NXP. And suspense. I don't want to unveil anything because I think your use case is super cool. The floor is yours. Let me share the screen, your screen, and you are live. The floor is yours. Good luck.
Okay. Well, hello. Welcome all to my presentation about Zeno on PX4 for multicast distributed networking between PX4 and ROS2 nodes. I think it's lots of jargon, but mostly we've been using Zeno Pico specifically for PX4 autopilots to communicate with also bigger system ROS2 based systems. So a short introduction about myself. So I'm Peter van den Berg. I work at NXP Semiconductors and I work for CTO System Innovations. And inside there, we have a mobile robotics team where we look on how to think about applications for NXP products inside this mobile robotics space. We make reference designs, we make development platforms, we think about networking, and NXP is quite big in vehicle networking. You think about the classical LIN, flex, CAN, but also Ethernet, battery systems. And on top of that, we also organize competitions. So we have Hover Games and NXP Cup, where you have these reference platforms for students to play around with. And actually for us, it's a very nice base platform to try new technology. So how does that look like? So this is a very brief system block diagram of mobile robotics. We have most of our legacy in CAN. So typically we're thinking about a CAN bus where you have different kind of sensors, RTK, GPS, but you see this, I would say, new revolution or convergence between cloud networking or normal PC networking, where typical Ethernet-based solutions also come in there, which also we have solutions for. We're showcasing. So we have flight controllers, vehicle management units. So we think about real-time systems. You have Linux systems. We have Ethernet-based systems, and then we have sensors and actuators. And this is kind of rough picture of our portfolio. And based on that, we make demonstrators. So this is just a basic presentation I use for the PX4 Autopilot Summit. So that's a autopilot to control drones. So some information is just quite basic. If people are familiar with Zeno, they probably know it. But roughly what we see is that this publish-subscribe pattern, it helps you a lot with software development because you can make separate nodes. If you look at the picture I had before, you have different kind of nodes, sensors, actuators, but you want to simplify that. So you want to think about a topic, you have kind of data topics, you have publish, you have subscribers using that data. So inside of PX4, even this concept is also used, and they use a inter-process communication. They made their own system called UARP, but this is just limited on the chip itself. So let's say you have a sensor node processing IMU data, and then you have an actuator for the outputs, but that just stays on the chip. But you see that these systems become more advanced and also more autonomous, and you want to even bridge those. So for ROS2, you see that DDS is used for that. That works on chip, but also off chip. But what we see is especially bridging DDS with small microcontrollers. DDS tends to be quite big. So roughly an overview of the middleware I've encountered working on robotics. So kind of like the typical ROS1 TCP ROS. So we had a publish subscribe. We needed a ROS1 master, so it's kind of broken connection. And with DDS, the nice part is that this became decoupled, right? So we can do peer-to-peer communication, and we don't have the dependency of this ROS master. It's UDP. Also, DDS brings some interesting technology regarding redundancy, liveness. So it's more in line with proper networking. But if we want to integrate it on smaller microcontrollers, we had some struggles. And I think since May this year, I saw that Zeno Pico was implementing also the peer-to-peer communication. That's kind of where we were like, okay, let's try to implement this on the microcontroller and bridge these two, where we can also have a small microcontroller participating in the DDS domain. And what I'm also very excited about is even that Zenoh now becomes an alternative middleware for ROS. So even we don't have to necessarily bridge, but we still have the flexibility for that. So very rough introduction on PX4 middleware. So PX4 typically is a FMU, which is a flight management unit. So that's a microcontroller that takes care of all the sensors, actuation, and tries to stabilize the drone. It runs the NUDX operating system, which is a small RTOS. And then internally, we have this MIORP to have all these sensors, attitude control, RC input. And what they do right now is they use a bridge mechanism, which is based on XRC DDS. And then they can use an agent to communicate with a ROS2 based system. Fortunately, what we had is we were also looking at functional safety and fallback mechanisms. If we want to add a second flight controller or other small embedded based systems, we always have to go to this agent. So that's what we really wanted to avoid. And we also have Ethernet switches and multicast solutions, and we'll go further into that. And we want to utilize that solution where Elixir DDS was kind of lacking for the things we want to use. But this is roughly how an autonomous drone system with PX4 could look like. Roughly introduction to Zenoh. So the nice part, what we liked about it, it scales from big systems to small systems, and also the fact that it supports different wire formats. So we still have systems where you might have to use serial, USB serial, Bluetooth. So even the things where we're looking at, we see that, hey, it's very extensible. And from the end user, we like the concept, okay, well, you can do this publish subscribe through this API on the high level, and then everything beneath it should take care of it. Well, should take care of it. That's the goal you have in mind, and I think Zenoh does a very good job also with the router and has worked it out nicely. So yeah, we come to the router part. So typically we are interested into P2P communication, but even the brokered and the meshing network is still very interesting for us as well. If we think about different setups, so if we think about a combined system, we could have multiple vehicles through routers. We could have a ground control station. That's the terminology they use for drones. So you're flying your system, you're on the ground, you have a 4G uplink, or you have other links. And the nice part, you can use Zenoh to route the data back to you to get real-time status of your vehicle. And if 4G, you can also bring that into cloud. So what you see that even if you think about the nice topology image of Zenoh, it really pairs nicely to multiple robotics system where you can have interconnection and have all these fleet control, and we can use one protocol for that. So that's really a concept we want to use. But mostly we just started with Zenoh to ROS2 bridging. So we have ported Zenoh to DPX for autopilot. We have a router running on a Linux system, and then we use the DDS bridge to bridge it with ROS2 nodes. So we had some challenge to port this. So still, if we want to communicate with ROS2, we also have to implement the ROS2 serialization. And that's specifically to DDS. It's called CDR. That's the serialization library. But the nice part is there is this Cyclone DDS implementation where you can use these serialize also as a separate library. And that seems to be small and portable enough to run on small microcontrollers. So what we did is we converted the internal communication system that PX4 uses to this IDL format, so we can generate serialized data for Cyclone DDS. And then we can serialize it the same way how ROS wants to have it serialized. And then the nice part is actually all the internal topics we now have on PX4, we can publish those to a Zenoh network, and we can decode it on ROS2, but also we can decode it on other systems. So how does that look like? Well, so this is the kind of architecture we are interested in. to think about redundancy. So we could have a flight controller, but even a second flight controller, but then you have to synchronize those states. And if you think about autonomy, you want to also add a companion system. So what we typically would have if you have DDS XRC as an agent or some kind of auto protocol MQTT, you always have to send from system 1 to system 2 to system 3. But the nice part about Zeno is that it's implementing multicasting. So the switch can already duplicate the packet for you, especially on small systems is important because we just want to send a single packet, and it's kind of like fire forget for that. So we don't need a broker. The switch takes care of it, and we don't have much overhead even if the network grows. And also the nice part is where you have these small real-time systems, we can utilize all the features that ROS has. So we can also use ROS specs for logging. That's one nice thing we have, so we can figure out how things are happening if we do want to test takeover scenarios. So yeah, it becomes very extensible. So how does it look like? So this is a very simple example. So on PX4, there's this internal topic, which is a remote controller. So there's a 2.4 gigahertz remote controller. We publish this on Zeno, and then thanks to the Zeno bridging, we can get the data over to ROS2. So yeah, you should see now, yeah, you get all the data, you see that the values are changing. We can look it in the ROS2 back. We can modify, we can also monitor this and also duplicate that. So this is the mostly the ROS2 bridging, which is actually kind of bonus because our primary focus was actually working on a redundant setup. So what we had is we have a remote controller. As an example, we sent this to a switch, and the switch does this multicasting. It gets sent to both flight controllers. They both have their own internal control loop, and then we can send out two independent actuation commands to the speed controller, and then either FMU can fill, the ESC can still operate. Also, what we utilize here is 100 base T1, which is 2-wire Ethernet, Automotive Ethernet. So this is the platform we use. So this is a small microcontroller that implements this 2-wire Ethernet. It's maybe you can see my cursor. Maybe I should turn it into a pointer. But this is just this very tiny 2-wire in-shielded Ethernet. So it does 100 Mbit. So you even need huge connectors. It's even smaller compared to CAN bus. And we get all the automotive functionality, which is also interesting still to look at the Zeno is the time-sensitive networking. This hardware is enabled for it, but we still have to experiment it. And then we have got a flight controller running on this platform. And then we have a very small switch. So this is 7.5 times 5 centimeters. So this is a 8-port switch that does this 2-wire Ethernet, and also for the sake of debugging, we can easily just put an RJ45. If you see compared to the small ports, RJ45 looks huge. And this is like an in-vehicle network for a small robot or for automotive. Automotive uses a lot now. But then what you see is that you're migrating from CAN bus to Ethernet, and okay, what kind of protocols can simplify that for you? So this is a demonstration of that. So in the center, we have the switch. We have one system that takes the remote control input. We send it to the switch. The switch acts as a multicast system. And then we have two systems controlling the speed controller. And then we have a nice visualization on how the motor should turn. Okay, yes, now the picture is working. So we are sending speed commands. We do the steering actuation. And what we now show is that either this CAN bus can fill, so we have it in the CAN bus, so we can just take out the CAN bus, but the system still operates because it takes in the same actuation command from the user. So this is a nice example where we can think about redundant networking setups. So for now in PX4, we have implemented Zeno Pico. It's still based on the old 0.5 5.7.0 functionality. I'm trying to work on the newest Zeno release, Dragonite. Well, also exciting about the Zeno Alternative RMW. So hopefully we can even do some experiments without using the router DDS bridge, just having a basic implementation. And yeah, crowd control, cloud communication through Zeno. I think this is a very unexplored area, and I think there's some opportunity there. And also, I'm curious if people are interested in here as well. Should I just put it? There's kind of like this unification of Ethernet campus through Zeno. So can we also maybe, like Zeno is quite versatile. You can use it on serial TCP UDP. Could you also use it on campus and even use campus networking for very small sensors? Like you have these voltage sensors or small buttons like a safety button. Can you utilize Canvas for that and then still bring that into Zeno and into the ROS or into other system where you can think fail-safe mechanism, but then from the end user, they can just use one same framework. So these are interesting things to explore. For now, we're mostly focusing, enabling it on our small microcontrollers. All we do is open source, so we try to contribute to PX4. I did some contributions to Zeno Pico. And for us, it's more to showcase our reference platforms. So thank you for listening to presentations. If there are questions, feel free to contact me. My email is also here.
So thank you very much for your presentation, Peter. As always, the question will be on social media, right? Because we are streaming live of multiple social media. So keep an eye. And otherwise, there are your contacts. So thanks again for your great presentation. And next is Sarah. Here we are. Okay, here you are, Sarah. So let me bring you online. Hello, Sarah. How are you?
Hi, I'm good.
Okay, perfect. So as you share your screen, Sarah, because I'm coordinating everything from here, so I decide what comes on the screen. Peter, thank you again. And see you soon, and keep us posted with your developments. And concerning Canvas, yes, I mean, this is something we would really look forward having. I was discussing as far as what was it last Friday with one of our engineer. He might end up doing a plugin for CAN that will already allow us, right, to so hopefully we should have that. And I don't know, Patrick, if you're hearing me. So you already know that lots of people are looking for it. We'll keep you posted. Okay.
Okay, great.
This is what we would like to have at least I would like to see in first instance. And then, I mean, we could have a profile of Zeno running on Canvas, but that requires a little bit more work, especially for very small, the lower end version of CAN.
Yeah.
So keep up with the great work. Thank you again, and stay tuned.
Yes.
Bye, Pete.
Well, thanks. Bye.
Okay, so Sarah, let me see. Hold on a second. Yes.
Well, actually, maybe I can share.
Yeah. No.
Do you see my screen?
No, I can see. Yeah, don't worry. I have the button that controls. What happens?
Ah, that's why.
Don't worry. Yeah. So first of all, thank you for being here with us. So for those of you that don't know Sarah runs essentially is Madame SDV or Madame Eclipse SDV, right? Because you run and you've done a terrific job in starting and making the SDV grow incredibly fast. So I think it's one of the most exciting working group at Eclipse as of now. And you will be telling about SDV, what is happening and the role that Zeno plays in this ecosystem.
Yes, thanks a lot for the wonderful introduction. My presentation is not going to be as technical as the other ones, so please do excuse me. But I'd like anyway to give you an overview about what our working group's doing and, of course, what Eclipse Zeno is doing within an automotive domain. So I did prepare just a slide about myself for the people that don't know me. I do run the working group. I'm the SDV program manager. But before that, I did study. I have a background in aerospace engineering. I did try my best doing a PhD, worked as a researcher for a bit. then decided to switch to the dark side and moved on to industry. Worked at a tier 1 organization for a bit, and then for an engineering consulting before finally landing at Eclipse just 1 and a few months, years ago, but it feels like 10. So yeah, we've been quite busy. In fact, open source in the automotive industry is surging. So you probably have seen that several automotive organizations rather independently have started to produce their own open source manifesto. So it all started with Mercedes and then followed suit by Continental. Porsche also has an open source platform, and then last but not least, ATAS partnered with Mercedes-Benz to devise their own manifesto. So slowly but surely, the automotive industry is also getting on board on open source. So, but I usually present what are the 4 freedoms of open source, but I'm sure you don't need to listen to this. However, what we believe is that open source is fundamental, but it might not be enough. In fact, what we also need are 2 very important ingredients, which is contribution and collaboration. And what I mean by contribution is that to ensure the transfer of IP rights to a foundation, such as the Eclipse Foundation or others, to make sure that you're not working in a single vendor setting. And collaboration as well, to enable to create an ecosystem that really plays on a level playing field and make sure that the rules are followed. And by rules, it means the governance that allows for a predictable and sustainable environment. Yeah, so what do we do at the Eclipse Foundation to support all of this? Of course, we make sure that the governance layer is in place, that we provide an open, vendor-neutral, and development environment to enable this open collaboration, which usually is located on the non-differentiating layer, or what we call the collaboration layer. In fact, the organizations that are our members, but not only, they do work below their value line, above which is essentially the competitive layer where they compete with one another. We make sure that we provide them an environment where they can work together below this value line. And this is where our SDV working group is located. And in fact, our mission, which is rather broad, is to create a forum, not only for organizations, but also individuals, if they are willing to build and promote open source software specification, and most importantly, open collaboration. Because what we want to create is a scalable, modular, extensible, industry-ready open source vehicle software platform. And this is a rather tough job that we set ourselves to. And in fact, we are very grateful to rely on a number of members that have been growing quite steadily in the last year or so, because the working group started in March. And we are happy to have a really great mix of members on board. In fact, not only do we have technology providers such as Microsoft, but we have the whole industry chain, meaning we have the tier 2, the tier 1s like Continental, ZF, and so on. We have the OEMs, Mercedes is on board, CARIAD, so Volkswagen, and GM. And of course, GM is the organization that is behind the U Protocol project. So they are also very much pushing for their for this technology and for open source in general. So I mentioned that what we as Eclipse Foundation do is we make sure that the governance is always followed. In fact, so what you see here at the bottom is what we always guarantee. So vendor neutrality, transparency, and openness. But on top of this, we also make sure that our working group is rather special, because differently from other initiatives, we truly are code first. So what this means is that we invest time and resources of the working group to make sure that our projects are as well known and as supported as possible. So our added value is really the fact that we have a number of open source projects, of which Eclipse Zeno is part of, to support our vision. And we do spend a lot of time and effort in making sure that these projects work with one another and that they are as promoted as possible. And on the other hand, we also, and therefore, ask for active participation. So all of our members are just not putting their logo there, but they really are taking steps toward achieving our goal and the program that we have set for the working group. So I'm gonna tell you just a brief history about the working group itself. So in the beginning of time, so all of the organizations didn't really know that open source was even an option. So they were always focusing on the dichotomy of making or buy something. And so every organization was an island, but then complexity grew too much. We are talking right now about more than 100 million lines of code for a standard car. So we're not even talking about, autonomous driving vehicles. We're just talking about standard cars. And this is a lot of code because it means a lot of money and a lot of time to develop it. So essentially, complexity is too high. Collaboration then is absolutely needed, and collaboration on non-differentiating software. And this is what our working group was born to achieve. So what we did at the beginning of the working group was to really live by the code first motto, and it means we onboarded a lot of projects that were fantastic, but they were all not matching with one another, and we ended up with what we call the SDV cake. It's not just a sacher-torte, but it's a really mixed cake. So what we did was to focus on, first of all, creating a community, so that people got together and really starting to know one another. And then we also try to start the mentality shift in senior managers, because finally they are the ones that decide how to allocate the resources. And then moving on throughout the year, we started to focus on project integration. So projects are great, but they need to work with one another. So what we are doing is we are trying to create blueprints. And blueprints are solution to a set of very clear use cases. And why we are doing this is that because we are code first, we don't want to have an architecture. So we don't want to start with an architecture that we say, this is the way the working group approaches a problem. But we want to give you building blocks, and we want to tell you how to use those building blocks, which means that we start by putting together this, what we call blueprints. And I'm going to present a couple of those to you later. And we also are onboarding a quite large number of tooling projects. So we have been starting to do that, to peek over the wall. This is October this year. So we have started to look at DevOps tools and processes. We are strongly involved in the European Union initiatives such as Federate. In fact, this is a coordination and support action that's basically it's a project of the European Union that kicked off in October, and where we are present and we are making sure that our projects are well known, are represented as much as possible, and that our community becomes the place for everything that's to do with open source software in automotive at the European level. And we've been very busy because we hosted a hackathon. We organized a full-blown SDV themed hackathon in Munich just a few weeks ago at Accenture, who was a fantastic host. And we had the chance to really bring our software with us to offer hands-on examples and hack challenges there. And going forward, we are going to hold our community day of Q1 next year in Graz. So that's pretty much the timeline. But I said we're code first, our projects are king, so what are our projects? And what do we mean by non-differentiating software? Is this more than middleware? Is there to it more than middleware? So, I mean, Yes, middleware is definitely a core section, a core fraction of what we do and where our projects are located. In fact, we have a very strong presence in middleware and framework, as well as communication protocol, but also in-vehicle digital twin, and Eclipse Zeno is clearly part of this category, together with our very exciting projects such as U protocol, eCal, and Cuxa, who's best known for being an outer abstraction layer for VSS specification. But also, yeah, we're having vehicle digital twin that are quite mature projects as well, such as Beiji. But we are not only there. So we are active in the runtime and orchestration block. We have right now actually two container orchestrations, BlueChi and Ankaios. And what's interesting here is that those two projects are sort of competing, but they do showcase how to work with one another within one of our blueprints. So we have a blueprint which is called software orchestration, which has the scope to showcase how can you exchange these building blocks together. So you can either choose BlueChi or Ankaios. They both are doing pretty much the same with different kind of optimizations, but they are interchangeable. And yeah, and also tooling and DevOps are a really big part of what we are doing in the latest months, because what we want to offer is really a true open source experience, not only for what runs in vehicle, but for the full experience of developing applications, because this is finally our goal, to speed up the application process. And we do this by designing a entirely open source DevOps chain, starting from the design towards the development, testing and validation, the deployment, documentation we are still working on, but we are getting there. So so we want to make sure that our working group is the home where you can really speed up your development by using entirely open source. Then another very important activity is, of course, the blueprint one. In addition, we have also other things such as distribution. So Leda, for instance, is a Yocto Linux recipe, provides you with recipes to essentially have really quickly a distribution with pre-integrated projects. Yeah. So back to the topic of what is non-differentiating software. So of course, a great example of it, and also where standardization is really helping, are communication protocols. So unfortunately, I missed the beginning of this presentation. I hope there was already someone talking about U protocol much better than I can do. But of course, U protocol is one of our main and most mature projects, with the outlook of going in series quite soon, and represents, of course, the glue that binds different communication protocols together. Is transport agnostic, is an ubiquitous language for discovery, subscription messaging, and more. And so basically apps and services can talk to one another the same language. So this is what U protocol does. It also brings the different pieces of the puzzle together. And one of the pieces of this puzzle, when it comes to the transport layer, is, of course, Eclipse Zeno, which, to my understanding, the integration is ongoing. So that's really interesting to see how Eclipse Zeno is working together with U protocol as well. But I wanted to mention something about our most important activity right now, which is the blueprint one. So an example of a blueprint is the fleet management services. So the problem statement is like fleet operators, for instance, they are required by law to collect a number of data points, such as fuel consumption, mileage, and whatnot. The challenge is, as you can imagine, is how do we get this very specific data out of the vehicle and into this fleet management system? And you can imagine there are different kind of hardware, there are different kind of vehicles, different kind of fleet management system, as well as cloud provider. So the solution is, of course, to leverage open standard and technology to make sure that the You can run the software on any vehicle. You are as independent as possible on any hardware, and that you can abstract and focus on APIs. So for that, we do have a blueprint, which of course has a architecture. You can check out the repository. There is code to it. There was also a number of hack challenges on this. So this is all running, and this is all entire open source. So what the scope is of this blueprint is we want to enable backend applications to consume data coming from a vehicle using the FMS API. And the data input, which you see here at the bottom, is just as an example. There could be other input, but we are here playing a CSV file through Cuxaval. So Cuxaval then passes the data over to the data broker, and you can translate the data in VSS, but then you can send this data to the FMS forwarder that writes the data over to an influx DB to the backend. So, and you can see it over here. And there is another option that you can use MQTT and pass your data over to Zenoh. And as an output, you can have a Grafana dashboard, for instance, and this is what you already see implemented, or the fleet management application via the FMS servers API, basically. So you can have this to outcome using Zenoh or programming this APIs. And here is where Zenoh, Eclipse Zeno comes into play. And it's an addition to our blueprint, which also showcases the modularity. You see, like, the difference between these two architectures are essentially the fact that there is a Zeno router in the middle that allows you to streamline communication, to distribute the data more efficiently, and of course allows also to have protocol plugins for different protocols and databases. And the idea to have Eclipse Zeno here in the middle is because it allows for a unified interface that you can, for you to access the VSS data that are provided by Cuxa here. So the information flow runs like this, that the Eclipse Zeno router receives the data from the forwarder over MQTT or over Eclipse Zeno itself, processes it, and sends that into the influx database. So there is no need for Zenoh, as you can see here, or for an MQTT adapter. So that's also a fantastic way to showcase what the capabilities of a historically IoT projects are whenever you put them in the context of automotive, because the boundaries here is not so clear-cut anymore, right? As we are moving and evolving in the automotive domain to use more and more of critical capabilities, then we can also piggyback on what is already done in the IoT domain, and Eclipse Zeno is a fantastic way to showcase how to do it. So we're really happy to see that guys are working together within this blueprint. And you can check out the issue here, and hopefully it will get implemented soon. And yeah, of course, when you talk about anything automotive, the first question that comes is, what about safety? So historically, there's a number of standards. There is the Automotive SPICE standard, which basically tells you a collection of best practices that are followed. So it gives you a blueprint for a process to implement. And then there is the functional safety standard, which is the usual ISO 26262, which is a collection of guidelines to minimize the risk. So the safety standard looks at artifacts that you provide from your software. So while the SPICE is a process, the functional safety standard checks the artifacts to assess whether you are minimizing the risk or not. And then there is also the cybersecurity standard, which is, again, another collection of guidelines to ensure that cybersecurity is, well, the risk is as minimized as possible. Now the question is, what about open source? Yeah, and as we know, Eclipse Zeno is a very mature project. And what we want to do within the Eclipse SDV is to make sure that we highlight what which one of our projects are as mature as possible. And clearly, we are not certifying projects right now within the Eclipse Foundation, but we want to make sure that we highlight the quality of our projects, and that we design a process for them to follow to make sure that they are as easily consumable as possible, and that the integrators can see how close they are to being certifiable. So this is also an activity where we need to have volunteers, and particularly projects that are very mature, to make sure that we can showcase how good they are and how close they are to being certifiable, which we do not offer. Yeah. Well, yeah, so I just want to mention that, yeah, we are participating in this control and support action. So we are going to have a quite good overview about what projects are going to pop up in this framework that the European Union is providing as a vehicle ecosystem. We also just won the HAL4 SDV, which is a research and innovation action for middleware, where we make sure, of course, that our projects are known and heard. And last but not least, you might have heard that that we just announced the Eclipse ThreadX project. So Eclipse ThreadX is a vendor-neutral, open source, and safety certified real-time operating system that counts over 20 years of development and was basically donated to us by our friends at Microsoft. So we are very excited to do this, and this fits perfectly within the scope of the SDV working group to create really an end-to-end entirely open source ecosystem. So we're pretty excited about it. And yeah, this is potentially an industry game changer. Again, open source is cool. Yeah, and with that, I'd like to thank you for your attention, and I'm happy to answer any question you might have.
Thank you, Sarah. So, yeah. Question asked online, because as you know, we are being streamed on YouTube, Twitter, LinkedIn. So you just have to watch out on social and answer them. Okay. Thank you very much for your presentation. Let me bring in and get prepared Nazmi from Felix, right? Which will be our next speaker. And again, thank you very much for sharing this interesting presentation with us, and all this insight about SDV, where it was, where it's going. And see you soon. Okay, so let me now welcome Nazmi. So Felix, super cool project at Felix, right? Going to revolutionize forklifting without forklift, right?
Yeah, let's call it intralogistics, yeah. Revolutionize.
So without further ado, just surprise us. So let me share your screen. Your screen is live.
Okay, yeah, you see my screen, I think it's perfect.
Yeah, we do.
Yeah, hello everyone. I'm Nazmi from Felix, and we are from Munich. And sorry that actually we're not there in person, but this is also good to have the opportunity to share and talk about what our vision is, what we do at Felix. So I'm actually not the person that should be maybe presenting this, but Marcus was not available, so I had to jump in for this meeting. So what we do at Felix, I will start. We reshape intralogistics. And what I do there is I usually do actually computer vision in Felix, but I will explain you what we do and what we try to achieve with our product. So when you rethink the forklift, we want to make this process somehow automated, flexible, and more intelligent. So that's why we produce an AMR that you can see in this picture, for example, that's automated and consumes a lot of less space, which makes it more flexible, and it's quite intelligent. And here I can show you actually with a video, it's so much better what we do. It's a simple transporting of a load carrier with our skids. Unfortunately, I cannot show the real skids in operation due to some non-disclosure things, but there we go. So as you see, the robots come underneath, and then with the minimalistic move, they can transport pallets in the warehouse. Yeah, let's move to that. If I can move to the next slide, that would be good. Yep. Okay, and sorry for this. Somehow it's not working. Perfect. And why are we better? So there are a lot of automations doing this, trying to automate intralogistics. There are a lot of companies, but what makes us different is actually we are breaking the intralogistic barriers. We are introducing new processes that we can do with this minimalistic size of our robots, and I will also talk about what else we do in the next slides. But for example, in this example, you can see if you had a big forklift, then it wouldn't be possible to pick up this red pallet and then take it somewhere. But with our skids, this will be possible while the skids go through the first pallet here, and then they will move to the red pallet, and then they will pick it up, basically. And we also want to shape truck loading and unloading, make it really fast. And this is one of the areas where in the warehouses, basically companies lose a lot of time. With the big forklifts, you have to go in there one by one and then take everything in. But here maybe you get a glimpse of our robots working together. This is our vision, where they bring the pairs of robots, bring the new pallets, and then they automatically go inside the truck. And then the whole they just leave, basically, because they are so minimalistic and they can leave through between the pallets. And we basically want to make this process really fast. Let's move to the next slide. I'm somehow having a problem with my presentation. Yeah, here. So Felix, that's why he goes the extra mile and does different things compared to the other processes out there, companies out there. For example, automation is done by most of the intralogistic AGVs and AMRs out in the market today. But what our difference is that we are the most compact unit. That's why we can do movements that are not really possible in small areas in warehouses, which is important actually to save space in a warehouse, so you can put more things inside. And we also provide greatest flexibility. And what I mean by this is that with the defined algorithms we have, we can detect and find different type of load carriers and then carry them around, basically. And we are not constrained to doing one specific type of pallet. And with this better processes example, as you see the pallet in the middle, the load carrier can be picked up by our robot. This is, for example, one of the processes we give. Now, about talking, before coming to Zeno, I will come to Zeno where we use it. And I would like to talk about the technical roadmap. So in unit 1, we wanted to do, and we did, just simply move one pallet from one place to another. And this has been done already, and then we are showing this in the customer use cases. As a next step, we want to do block storage operations and line storage operations. What I mean by that is the picture you're used to now is picking the block as a whole and then moving the blocks, or picking them one by one and then picking them from different locations. Basically, this is what we can provide. And afterwards, we want to move to swarm operations, where we can move the blocks of pallets together, and then they will quite much autonomize the transshipment process. Maybe some people are not familiar with the transshipment process. So normal in a warehouse, there's the section where we have to take the workers, have to take and from one truck to the other one, which then transports things between the cities. This is a tedious process if you have to do it one by one, of course, and then if you imagine this autonomized, then it's quite time saving actually. And as the last step, as our vision, we want to be able to fully autonomously load the truck and unload it. Here I also give a full video of our vision, the Felix warehouse vision. I will just start the video. Here you see our autonomous robots working together to carry around different pallets and at the same time load trucks. And this warehouse, as you see, is working completely autonomously. And this is actually closing the horizontal automation gap. But for this, as you see in this video, we have a lot of robots working together. And as some other robotics companies before me explained, when you use ROS2, the native DDS option is kind of actually not an option for you, because there's the discovery delay, it's so slow, and then you have to really communicate reliably, especially in our case with a quite real-time operation. And this is quite important because we also have two skids and they also need to communicate between the two. That's actually where Zeno comes into play when I move here. So why do we use Zeno? We were using native DDS, and this is actually not really scalable. And when we go do pilots in the warehouses, the network quality is especially bad. And for this, we have to introduce some sort of different way to distribute the topics that we need for our robots to run reliably, basically. And as Rodrigo before me explained, this is costing a lot of, in terms of CPU and networking, a lot of energy to you. That's why we wanted to move with Zeno and then highly optimize what we want to distribute between and actually just get rid of this overhead of discovery traffic. And how we do that? At the moment, we do this with Zeno Bridge DDS, this bundle tool, and it's quite useful for us. I don't have a diagram to show it, but we run in each of our skids Zeno Bridge DDS with the topics that we want to communicate between. This could be services, this could be topics, could be a lot of things actually. And with the help of Zeno Bridge DDS, basically, then we can run in a quite poor network area, and we make sure that we have the correct data between the robots, because they really need to know each other and where they are and etc. And what's next, if you move to what you want to do next, is recently our CTO has visited, I think, ZettaScale, you will remember, and he discovered there as well that this Zeno Bridge ROS2 DDS. So we will move to Zeno Bridge ROS2 DDS, where I believe the RVIS is more reliable as far as I understand. We will move to that, and we got some quite good insights on our use case, what we can use. For example, at the moment we use UDP discovery, but we want to try the quick as it was suggested to us. We will do that. And so Zeno is going to be in our life for sure for a long time, and we are actually quite happy with it, and we would like to also contribute later when it comes to it. We had, if I remember correctly, one issue with the QoSs in ROS2, but we were sure that also like the help from Julian was quite there, that he told us what we can do regarding these solutions, and we want to also try later in between Zeno router and basically group the robots together, like how Rodrigo showed in between. At the moment, we don't use the Zeno router. We just run Zeno Bridge DDS with the corresponding IPs of the robots. And this works well for us, actually. but later we will try those. And with this, so in general now, this is one of the things that, of course, we have to do to make sure the communication between our robots is really well, because they will be working together in the warehouse. And we have been in production now. I'm not production, building the tech for 4 years now, and research and development is still taking place. But nonetheless, we started doing market projects, and we are partnering with at the moment with warehouse stakeholders, and they have the potential to get 1,000 units from us. I think there are 8 or so companies in this regard, our partners, and we are doing POTs and POCs with them. And Zeno is helping us quite a bit there, especially in the warehouse when the network is not so good. And yeah, so with that, thank you for listening. And if you have any questions, please feel free to reach out. And I don't know if you guys heard me through this presentation. I hope, because it was.
Yes, it was, I think, very good presentation. So thank you very much, Nazmi.
Yeah.
So let's thank Nazmi.
Thank you for listening.
And, best of luck with moving forward with Felix, because your project is super cool, right?
Yeah, thank you. I'm sure we will be in touch.
I was expecting to see you with a shirt.
Yes, I have the shirt, but the thing is, it's so cold here, and I didn't bring it. I have the shirt, and I use it.
Cool. And so, yeah, we were discussing some interesting things with Marcos. And
yes.
Anyway, so looking forward to experiment some of those.
Yep.
Very cool. Okay, so hold on as we welcome Yadu and Franco. Hello, Yadu. Oh, beautiful t-shirt, Yadu. I love that.
I had to.
Hello, Franco. How are you guys?
Doing great. How are you?
Great, thank you. So we are now, across multiple continents, because Franco, you are calling from the beautiful Argentina, isn't it?
That's correct, yeah.
Yeah, and Yadu, you are based in Singapore.
That's right, Angela.
Yeah, so great. Okay, so Nazmi, again, thank you very much.
Thank you, and I will look for the questions on the social platforms.
Online, great. Yeah. Let me phase you out. And very short intro. So Franco and Yadu are working on, Yadu for Intrinsic. You are a consultant, right? Working for Intrinsic. I'll let you give you guys more context. And are doing some key work on the alternate RMW, right? So, which I guess what you will be sharing. So I'll let you do the full intro. The floor is yours. Best of luck with the presentation. Have fun, more importantly, right?
All right, inshallah. Thanks a lot for the introduction. So hello, everyone. Thanks all for joining in this occasion. I'm glad to be presenting along with Yadu about some work that's been going on for several months now. This work lives within the ROS2 ecosystem and is focused on a new implementation of the ROS middleware. Here it is. Okay, so who are we? My name is Franco Spolone. I work at Ecumen, and for the last couple of quarters, I've been working as a ROS developer in this effort, along with other people from the ROS team. The second half of the talk will be presented by Yadu. He's also from Intrinsic. He's from Intrinsic. Yadu, I'm not sure if you want to present yourself. Right? Yadu has been acting as ROS boss for Iron distribution and has been a crucial contributor to this new development. So what are we gonna do today? We are gonna be talking a little bit about the ROS middleware just to understand the context of this effort. After that, and more related to the investigation process, we are gonna dive into the requirements that we gather for this new development. Later on a general
a general comparison among middleware options, and finally, we will comment about the current status and future work of the new ROS middleware implementation, which is called RMW Zeno. You can imagine why that name. So let's start with the ROS middleware. For the sake of the presentation, I will assume we all know a little bit about what ROS is, just at a general level. If this is the first time you heard about ROS, then I might resume it by saying that ROS is the most widely used open source development kit for robotics, and it's definitely a tool worth to be checked out if you haven't already. So, regarding the ROS2 architecture, oh yeah, are you seeing? Oh, sorry, some issues with my browser. All right, so regarding the ROS2 architecture, it is based around abstracted communication, which provides a convenient modular interface for developers. Starting from the top, you have your ROS application that is built on top of ROS client library. For example, the RCL CPP is the CPP API of the ROS client library. Same thing for the Pythons and so on. Then that is built on top of what we call the RMW or ROS middleware layer, which is basically an abstraction that interfaces with the actual middleware used for communication. The RMW API allows you to plug and play different implementations. The most commonly used middlewares here are FastDDS and CycloneDDS. However, there are other implementations relying on either or other middlewares. Worth noting that this API allows this layer to be swappable with other implementations. You can use FastDDS, for example, and then switch to CycloneDDS, or even switch to a custom implementation. In fact, this abstraction is what led us to dive into developing a new RMW implementation, in this case, using Zeno under the hood instead of DDS. So, the reasons we embark on developing a new alternative middleware are related first to the fact that even though the RMW interface is meant to be generic, you might find that it's a bit linked to the DDS implementations, and this probably makes sense as all tier 1 official implementations available are DDS. Therefore, we expect that with a new non-DDS RMW implementation, we will be able, probably in the long term, to make the RMW interface even more generic. Another motivation for this alternative middleware was that when using DDS, even though it works for most applications, it generally requires some careful tuning to match your use case. And this makes ROS2 probably not being as pleasant as out-of-the-box experience. For example, you might find some failures from UDP multicast in DDS, some discovery failures due to scaling issues of UDP multicast. The multicast service isn't always allowing routers or large Wi-Fi networks. Also, difficulties transferring large payloads. This is typically problematic in Wi-Fi networks where the connection might be unreliable. So, as a summary, the various DDS implementations have many configuration points. However, it can be overwhelming for users, mainly for new users, to figure out which tuning parameters they need and for which reason. So after identifying the motivation, we proceeded to define the requirements for this new ROS middleware implementation, and by extent to the underlying middleware to be used. So we gather requirements via several sources. There are some known ROS2 use cases that we use as baseline, also via targeted interviews with key stakeholders in the ROS community who share many insights from their use case. And we also sent out a survey to the ROS2 community. We got almost 200 responses, which helped a lot to understand the user and identify requirements. Here, some insight from the survey. Here, we are showing first some demographic information obtained from the survey regarding organization size. The half of the respondents were from a small business organization, while the rest refers to large business, academia, and research organizations. Regarding the scale of the robotics application in terms of number of robots, we can say that the half of the respondents have small fleets of robots, less than 10 robots or so. However, applications with 10 to 100 robots are also significant, according to this survey. Regarding the typical number of topics in the network for the application, it's dominated by we can say it's dominated by a range between 20 and 200 topics. Continuing a little bit with the information from the survey, regarding container technologies, Docker and Pullman were indicated for the majority of the respondents as the technology being used. And regarding network topologies, we can see that there is a common use of localhost only, Wi-Fi, cellular network, VPNs topology that probably stand out from the others. All this information helped us a lot to understand all sorts of requirements before actually diving into analysis of the middleware options and in the implementations. And now I'd like to turn things over to Yaru, who will continue with the requirements.
All right, thank you, Franco. Good morning, good evening, everyone. My name is Yadu, software engineer at Intrinsic. I'm happy to walk us through the rest of this presentation. So as Franco mentioned, over the development of ROS2 over the past 8 years, we've unearthed certain issues that users are facing with regards to DDS and discovery. And this sort of prompted us to go down this path of identifying the next middleware to use. We wanted to be very systematic about the study that we perform. So our goal is to have a list of middlewares we want to evaluate, but also define certain requirements to evaluate them against. And as Franco mentioned, we had 3 different sources for getting these requirements. Internally, we know what ROS2 needs to be able to do, but we also spoke to several key stakeholders and maintainers of large popular repositories within ROS2. But more importantly, we had this user survey that helped us understand better of what sort of applications are more important to users. So all of that information was synthesized into these requirements that you see here. And the level that we use to quantify or qualify these requirements follow RFC 2119, and it just tells us certain keywords or standardized keywords which we can use to evaluate the level of a requirement. So here we're using must for something that is important, is extremely important. We have should for something that's recommended, and may for something that's optional here. So if we look at some of the must requirements, pub sub is at the top of our list, and that's something that's critical for a lot of our users. It's the bread and butter of ROS2. RPC, or remote procedure calls, has been assigned a level of may, and that's really because we see RPCs as something that we can also implement with a pair of pub subs. So at the bread and butter, we need pub sub to work. ROS2 is meant to go into production environments, so security is extremely important. And we classify security or break it down to 3 different categories: encryption, authentication, access control. We also want to be able to handle reconnecting to the network, or handling network disconnectivities, or handling other sorts of bandwidth issues on the network itself. And that's extremely important to us because robots move in various environments where the network connectivity really varies over time. Or you could have robots that go into elevators or go between rooms, and then they might intermittently lose connectivity, and that shouldn't, bring down the entire system. There should be some sort of resilience to connect back to the network. So that's something that's very important to us. We talked about discovery quite a bit as some of the issues we face with DDS. We have built-in discovery at a should level here, because we feel like this is something that we can also implement. It's not important that the middleware provides a full discovery service out of the box, but this is something that we should be able to implement so that we can introspect what's going on with the different nodes in our graph, understand who's publishing what information, and also just get some statistics in general. So I think there's a lot more details on each of these requirements within our report. So I'll save us the trouble of going through each one of these items in the list. There's a link on top. Please feel free to go check it out. There should be detailed notes on each of these requirements. Let's go to the next slide. So we took all those requirements, and then we also came up with a list of middlewares we want to evaluate. And these list of middlewares come from that user survey we conducted, but also some insights that we have into the industry, and as well as some other protocols that we wanted to try. So as you can see here, we really evaluated a good variety of protocols that are written in different languages or based on different frameworks. But overall, the goal was to take these middlewares, take the requirements, and then come up with a list, come up with a table, a matrix table to evaluate each of these middlewares against the requirements. And that's really what we have here in this next slide. So again, it's a super dense table, and I don't want to take up the time here to go into how we did this evaluation or how we scored each one of these middlewares. But the key idea is that this report is publicly available. Please click on that link later on and check out this table. You should be able to see exactly how we scored each of these middlewares. But I just want to highlight right now of how Zenoh did across all these other middlewares. As you can see in the slide that's highlighted, the column in red, that's the entry for Zenoh. And you can see a lot more green than red. So that should be an immediate indicator that Zenoh fared really well against our evaluations. The boxes or the rows for which we had to score it, that you see in yellow here, represent certain features that don't exist today, but are committed on the roadmap for the middleware. So in this case for Zenoh, things like shared memory or perhaps access control with security is not available at the time we did this evaluation, but we know that it will be ready by the time we need this to be a stable middleware solution. So across all of these different middlewares that we evaluated, Zenoh definitely stood out to us the most. So in the next slide, we'll just talk about some of the highlights in comparison to some of these other middlewares. So Zenoh by far meets most of our requirements. And like I mentioned, what it doesn't meet right now, there is a commitment from the ZettaScale team to have these features in for us. If we look at some of the other top contenders that came out from this evaluation, TCP ROS was the second best performing middleware. And this TCP ROS is basically the custom middleware that we wrote for ROS1. And you can imagine how popular ROS1 is. It works great under various situations. The only downside is that it's kind of brokered. It requires a central ROS core to be running to be able to forward discovery information across different participants in the network. And that became a central point of failure, which was what the prime motivation for relying on a peer-to-peer topology with ROS2 was. So there's no surprise that we saw TCP ROS here. Some of the other contenders that we saw were MQTT, which does meet a lot of our requirements, and it's used extensively in the IoT world. But the key limitation for us, on top of being brokered, was the fact that it has limitations on the payload size, or the messages that we can serialize and send over the transport layer. So that was a big limitation for us. ZeroMQ is also popular, but and as a matter of fact, we use it in Gazebo. But ZeroMQ is really a toolbox or a set of APIs that you can use to write your own middleware. And for this purpose, we don't want to spend too much time writing a middleware that fits all our requirements. Rather, we want to see what already exists, what's mature out there, and apply it for our applications. We also went through OPC UA and Kafka. OPC UA, while it meets some of the requirements, the architecture doesn't really support some of the features that we're looking for. It doesn't do any sort of discovery, and it's also, in a way, centralized. Finally, Kafka was interesting, but it seemed way too complex to configure for a beginner user, or effectively configure for it to work with multiple systems at the same time. I do want to highlight that all this evaluation that we performed was pretty qualitative. We left performance analysis out of the scope of this evaluation, as we found that in the past, every time we evaluate some of these middlewares, it's really subjective to how well the middleware is tuned. So Franco mentioned there's all sorts of parameters with several middlewares that you can configure. So more or less, you can get the same gross performance when you tune each of these middlewares. But what we're really looking for here is that out-of-the-box simplicity and also friendliness for new users. It was nice to see that from the results of the user survey, if we rank what were the popular middleware suggestions from the community, Zeno was #1. So it's great to see that we kind of independently arrived at this conclusion, both from our systematic study as well as a popular vote from the community, that Zenoh should be the next middleware that we rely on for ROS2. All right, having said that, I'd like to spend a couple of minutes giving an update on the status of our RMW Zeno package. So RMW Zeno is the ROS2 middleware package that we're writing that's based on Zeno. And it's a C++ package that relies on the Zeno C bindings to implement certain interfaces defined in the RMW package. So as Franco mentioned, RMW is that API layer which you use to derive or implement your middleware specific functions. And then this is something that's swappable at runtime or compile time in ROS2. So we want to make it such that users can just change a single environment variable that says, use Zeno as my middleware, and then boom, all the nodes are communicating over Zeno. And that's what this package does here. So our goal is to have this, have the source version of this released by Jazzy Jalisco. So that's coming out in May 2024. And right now, a quick progress update on this is we have PubSub working in certain graph introspection features. So we're able to kind of query the ROS graph to know who are the publishers, subscribers, what topics are being published, what nodes exist, etc. And we're currently working on implementing support for clients and services. Another feature that we're also working on is supporting a variety of quality of service settings. And that's something that will hopefully come in really soon. Cool. I'd also like to talk a bit about the topology that we've adopted here for RMW Zeno. So the great part about Zeno is it works in so many different topologies and it's different network configurations. We chose something that we felt would work across various robotics use cases and is simple enough for people to use out of the box or with minimal configuration if needed. So we're relying on the Zeno D router to act as the broker purely just for discovery information. So this is a service or a daemon that's running behind the scenes, and it's just forwarding discovery packets around to different nodes. So the way it works is every node sort of publishes or advertises itself over UDP unicast. So there's no UDP multicast enabled anywhere that was causing all the nasty discovery traffic issues before. So UDP unicast is used to just broadcast discovery information from a peer to the router directly. And anytime a new participant joins the router, it's given the information of the previously connected peers from the router. But the payload itself is transmitted peer-to-peer. So this is not going via the router. The router is not acting as a broker for the information. So this is going to make transport pretty efficient as well. So Zeno APIs, I should clarify that the Zeno session did not allow us to directly introspect the graph of the peers. So we're not able to query using any APIs to know what nodes exist, what publishers, subscribers exist. But we were able to implement something using the liveliness token feature from Zeno. In this slide, I just wanted to highlight some of the improvements or additions that came into the Zeno C API as a extension of this work that we've been doing. So our team has been in close contact with the ZettaScale team, and we've been working together on this RMW development. And along the way, we've identified certain features that would be nice to have in the Zeno C API that already exist in the Zeno Rust API, for example. And I just wanted to highlight that two such important features we had ported over to Zeno C were liveliness token support, as well as this publication cache and querying subscription functionality. And the latter is really going to allow us to support transient local durability for quality of service. So for people who don't know that, you may have a publisher that published your data once, and then you may have a subscription that joins the graph at some point later in time. So this subscription needs to have a way to also get this information in that was published once. And that's really what this feature is going to help us with. So in conclusion, we feel that DDS is here to stay, but we strongly think that an alternative middleware protocol is beneficial to the entire community. And from the results of our study, which are both community-driven, but also driven based on 8 years of experience of working with ROS2, we feel that Zeno is definitely the preferred choice for this alternative middleware, given how well it handles discovery, as well as transferring payloads over a variety of network topologies. I'll just conclude by saying, please look out for our source installable version to be available by May next year. And we hope to have a lot more improvements and code quality fixes and bug fixes and much more stable code available for everyone by KTurtle in May 2025. Thanks again for ZettaScale for organizing this. It's been a great process so far. Looking forward to wrapping up this work. And I'm just excited to be here. You can tell by the shirt.
Yeah, thank you guys. And I know it has been a journey. It was been, as you know, we were proud and surprised and thrilled and scared at the same time, right? Because it's a lot of pressure. I think lots of emotion were flowing, but it has been great working together. We are really impressed by how quickly you guys are progressing. And so, look forward to more of this. So thanks again for the presentation. Let me thank you all. Yeah, thank you guys. So let's bring up Stephen, which is coming up next. So before I let you guys go, hello Stephen, how are you? So we had now Northern America, right? Stephen from GM connecting out of Canada. And so thank you again, Yadu and Franco. I'll let you follow up with question online on social media, and yeah, I'll catch you up later. Thank you guys again. Keep up with the great work. Thank you. Bye.
I think this is actually a phenomenal segue, because we're doing that same initiative that they did for Russ, coming to the same conclusions, working on the same integration, and actually learning about that pull request number 189 and 191 is going to address some of the questions that I have in some of our chat channels. So this is
okay, great.
This is good, because we have that same gap, trying to map it to what I'm going to talk about next. So.
Yeah. So quickly, and then I'll let you expand on the intro. So Stephen Hartley from General Motors, working on U protocol. So you were one of the forces that brought U protocol into the open source, right? And this is essentially what you will be discussing. Also tying in, I don't know if you had a chance to see, Sarah did. Yeah. Okay. Perfect. Okay. The floor is yours. Let me share your screen. So your screen is live. Best of luck with your presentation, and I'll see you in a little bit.
Okay, perfect. Thanks for the introduction. And also, I'm not sure if you're still on or listening, Sarah, but thank you for the summary of U protocol. What I'm actually going to talk about today, first, before I dive into what we're actually contributing to the open source, is talking about GM's now embracing of open source, which is kind of a shift in mindset from what like Sarah was mentioning, something that historically we would pay large companies to build software that would be put into hardware components that would not be changed over time. Now we're talking about adopting open source, and not only adopting open source, but actually contributing to open source and learning from the community as we go. So, why are we doing this journey? Sarah was mentioning something called the software-defined vehicle. There's that saying that it takes a village to raise a child. And that's what we're realizing with a software-defined vehicle. If you want to build a vehicle that has, complex applications and features that don't just reside in one hardware component inside the vehicle, but actually span outside of the vehicle to devices connected to it, infrastructure, and so on, you really need to come up with some sort of an architecture and a communication protocol framework that allows that ease of software development. So we're embracing the open source because it just takes way too long for us to develop features and functions. Our architecture, like you see the diagram on the right side, that's kind of like what our vehicle architecture is today. Most OEMs, other car companies, they have these static networks that are based on CAN and LIN, and there is Ethernet in a lot of our vehicles, but it's we build a module, we put it into the vehicle, and we forget about it for 20 years. That doesn't work when a customer is demanding and expecting new features, new functionality in their vehicle for many years after we ship it. So additionally, what happens is we need to no longer fragment our software. So we need when we're developing software, it should be easy and simple for a developer to come on board and write something that has to have a portion deployed into the cloud, talking to some software in the vehicle, or adding a feature to the mobile phone shouldn't take 150 engineers across all the continents and 10 time zones and 3 years to do. That's what we're trying to get away from. I mentioned about that, and also a lot of the solutions that have been coming forth and has been developed so far, they're very OEM specific, or we have these large solutions from companies like Google and Amazon and others that build these application frameworks, but then it doesn't necessarily work across the entire vehicle. I need something that can run at the deeply embedded mechatronics, high compute, between the connectivity module into the cloud, talking with the mobile, talking with infrastructure, and it all has to be the same from a developer perspective. So what we're really doing at GM, which is a lot of OEMs are doing as well, is we're embracing the open source. So moving to an open source Linux-based solution for the core kernel and operating system. So in conjunction with other partners that are working in the automotive space, like Red Hat, is in the development of a safe version of Linux. It's called Safe Linux, that is ISO 26262 compliant. We've also, excuse me, we've also partnered with like Sarah was mentioning earlier, we're partnering with the Eclipse Foundation and working on a communication protocol that maps very well to Zeno, and I'll talk about that afterwards, because of the goals that I'll talk about afterwards. So we're actually contributing a lot of code, and what we're doing is we're actually no longer with the mindset of developing something in-house and then sharing it. Well, first of all, we didn't share it before, now we're actually sharing it, but also it's engaging with other car companies, tier ones, partners like ZettaScale and others, in actually developing this code on the fly to benefit the community. Additionally, another part of building a software-defined vehicle is kind of having a rich set of APIs and services, the data model of the vehicle, let's say. So there's been organizations like Covisa that have been spearheading that initiative, and GM started developing something called our U services that work with U protocol. And these services is just a catalog of feature functionality that you would normally see in a vehicle, so that we can standardize on our APIs for anybody to create applications, because we would love to be able to focus all of our energies on building rich set of apps and services for the customers, and not the infrastructure, the communication platform, and all those other underlining things that we hope we can just eventually take for granted. So why with U protocol? One of the things that we've noticed is that in our vehicles today, there's a lot of different communication protocols. There's a lot of automotive-centric ones. There are internet-based ones, and they don't always interop with each other, interoperable with each other. For example, if you look at an MQTT solution, I might not be able to take an MQTT broker client solution and have it work in a mechatronics environment. In our highly restricted mechatronics world, everybody uses the SUM-IP standard. It's something that is well vetted. There are a lot of off-the-shelf solutions. There are open source solutions that are coming. And so we would like to be able to have these things interop with each other. And so, like I mentioned before, these apps and services are highly distributed across all these different services. So, our goal is to be able to publish mechatronics functionality in a common way and have cloud services subscribe to them. Now, along the route, it might be, from SUM-IP to Zeno to MQTT to, Azure Event Hub. Why? Because, I'm going to take off-the-shelf solutions that is provided by, the different environments that these networks are connected, and I need them to all interop with each other. And as much as Zeno is becoming that potential end-to-end solution, we still need to have these apps and services run and operate and work across all these different technologies. So that's why we said, why don't we just define a standard way of communicating for pub sub and RPC, kind of like the set of APIs that the folks at Ross was talking about, and build this rich set of APIs and libraries and functionality on top of it that then maps to Zeno, or maps to MQTT, or maps to some IP or some proprietary technology that might exist. In the case of Eclipse, we have so many that are coming out, like Summer, P3Com, eCal, many other different type of technologies that can map under uProtocol for the developers to just use uProtocol. We needed some sort of a way to standardize the mappings, right? Because if somebody says something is priority P3, but another person calls it CS2, we need some way to agree on what the definitions of priority is, the definitions of all the different attributes that you would use when communicating. So that's really why we wanted to come up with uProtocol. And when we were defining it, it felt like it was a commodity that we need to put out there, and not something that GM should just do on our own and implement to, because we want it to be deployed and used across many different areas. So then it comes to why Zeno, which is very interesting, the previous presentation as well, because we're coming to the same realization that, well, actually Zeno implements very well a lot of the concepts, a lot of the ideas, and a lot of the optimized the concepts and technologies that we want to do with uProtocol. It provides this lightweight, very efficient pub sub solution, pluggable architecture, so we can plug it into others as we need it. So by that I mean, if you go to the Eclipse project and look at uProtocol, we talk about these bridges that are at the edge of the different devices. And from here, what we can do is that maps very well to the Zeno router concept. And then from that, it's easier for our developers to say, oh, I can create a Zeno implementation of this for this use case or that use case, and so on. And so what we've done, rather than just from one OEM to a supplier and let's just behind closed doors, write a check and talk to each other close, we're going with the open approach to bring the community and the open source along with us. So we have now open sessions that I'll talk about in the last slide, where we are working with ZettaScale, working with the authors of Zeno to allow it to meet the requirements that we have in the automotive space for safety, security, robustness, quality, making it compatible with uProtocol to pass the attributes that we need, that maybe is not needed in one environment, but it's needed in another, so we pass it along so it can be sent from end to end and so on. So we're working with the community to bridge that gap, to provide a Zeno solution for uProtocol, just like there was a Zeno solution for the ROS, which was very interesting. And from that, just the last slide, talk about, in the Eclipse community, which, like Sarah was mentioning, there are other car companies, Mercedes, Volkswagen, BMW, you name it, and also tier ones and other technology providers like Amazon and Microsoft and others. So we're starting a communication-focused working group where we're talking about if we say that uProtocol can be the common way for the glue that everybody talks to each other, then let's map that to all of the possible communication protocols that you might have in a car. And one of them being Zeno, another one Summer, another one MQTT, so on and so forth. And so we have these working groups that we get together, and we talk about the requirements, talk about the status of the APIs and the progress of Zenoh technology to be then taken and used in our vehicle, not only for modeling or bring up and testing, but actually controlling and running the critical ASIL B-like functionality of autonomous vehicle for perception and other functions as well. So Sarah mentioned about a blueprint. There's an initiative we're going to create as well with the blueprint kind of linking all these things together, because a true end solution would be showing a mechatronic service publishing something to an application that's running in Zenoh, that's in the high compute, and it's also publishing information to the reference Microsoft platform that is also consuming it over its technology, its event hubs and event grids and all the other things that they provide as well. Same with any other, cloud provider as well. So yeah, it's a pleasant. I also have to say, as a closing remark, it's a very pleasant engagement working with ZettaScale. Very different from working with other companies, I have to say. We have done so much in the open in our current engagement, so it's and full of extremely smart people. Just want to give you an example. There was one other developer from some other company that wrote a Rust reference library for U protocol. And then the Zenoh team, and Luca in particular, jumped in and started doing code reviews and providing all of the insight and feedback. Now we have something that is not just a GM initiative, but we have it from many companies coming together to build this solution for the automotive industry, just like the ROS solution is for building for the robotics community, which is pretty exciting. So
thank you for the nice word on ZettaScale. Thank you very much. Right. And thank you for the presentation. I mean, this is how we are. I hope that comes across. And I mean, I think all of here, all the team was here to hear those. So, I mean, thank you. Thank you for the presentation. And our next speaker actually is here. So I will, it will just come next to me as opposed to pop up magically, right, as a video. Here, let me squeeze you in. Right. So he comes actually from Belgium. He drew from Belgium. Oh, we have lost you, Stephen. You're already gone? Hold on.
Nope, no, I'm here.
Not quite. No, we always do. We always do this kind of intermezzo in which.
Okay.
So it makes it easier for also the next one who is going to go live. So we are going back to robotics, another pretty cool use case. Quite long time Zenoh users, isn't it? Yeah. So I guess the floor is yours.
Thank you.
Okay. Thank you again, Stephen.
No problem.
Ciao. Bye-bye. Thank you.
Yeah.
Okay, so let me bring up your slides, which should be here.
Just refresh as well?
Yeah, of course. I will first share the screen. It's full screen. So that should be good. Here we go. The floor should be yours. It is yours.
So thank
Enjoy
you.
the presentation. Thank you.
I first want to thank everybody at ZettaScale to actually invite us over and have this cool opportunity to talk to the ZettaScale and to the Zeno user community. So my name is Elias de Koning. I'm a senior robotics engineer at Tractonomy Robotics. Like Alejandro mentioned, we are actually based in Belgium, in Ghent. We build an automotive mobile robot. Oh, apparently my slides are not online.
So. Okay, so that's the thrill of the live, you see? So let's see what's going on. Oh, it says unable to share screen. Let's try again. Okay. So guys, can you confirm that now you can see the screen? Someone?
No.
No? So let's see. I mean, should be good now. I think it's good. No? I think it got tired. Well, worst case, you will have to join from a laptop.
Yes, I have the link as well.
Everything was way too smooth, right?
Yes,
Yeah.
of course it was.
And this is the paradox of modern times,
to
right?
quickly
In
take my
which
laptop as
in
well.
which the one that that doesn't work is the one when you are in present. Okay, look, we woke up again. Allow to share screen. Let's see. Let's try again. Screen. I think you should be sharing now. I don't know if you can. Yeah, no, I don't think this is working, guys. No, it's just bugging. So let me just share a screen. I'm posting a link, guys, on Discord for all of those of you that are going to present next. Okay, on Zcore. Unable to share screen. Can you guys see anything by any chance? Okay, let me do something. Actually, I have an idea. Yeah, but then I will have. Okay, guys, I think I solved the problem. Yeah, that's working. I just solved it slightly differently. Yeah, okay, good. And now you guys should see the screen. But I need to do something else. Hold on a second before we do that. Okay. That should do the trick. Oh, here we go. Okay.
So, new start, and let's hope that everybody can hear me okay. I have a bit of feedback because I think the...
No, but again, there is... Oh. Yeah, so I think that... Okay, so this is the Zoom. There is there is still some echo.
Online, not, but I think it's because this one is delayed. You just lowered the. Okay.
Yeah. Okay. Then
just
let's
lower
go.
the
Yeah. Then
microphone.
let's go. Let's just lower that. Yes. No, that's exactly what is happening, I think. Yeah.
Yeah.
Yeah. And this
one
is
needs
what
to
we're
be
going to
muted.
do. Okay. The floor is yours.
Okay, so sorry for the short delay. Actually, we're right out again on time, so this delay was just like a bit of
Just to catch up.
just to catch up. So let me rephrase it. I'm Elias de Koning. I'm the senior engineer of the senior robotics engineer of Tractonomy Robotics, and we're based in Belgium, in the city of Ghent. And we're actually designing and making AMR, an automotive mobile robot. We do that with a rather small team, so we are currently with 6 people. Keshav, which wasn't able to make it here because he's actually going to join Roscon in India. And Geert is our main machine designer. He's actually building the mechanical hardware of the robot. And then me designing the software using Zeno and all the middleware and ROS to build up. And then our newest member, Francisco, who's helping me with the software. So we are actually have already a couple of investors. One of them is the European Commission, some Flanders-based investors, and then also some VCs that we joined. We are part of the IMEC R-Start from Belgium. That's one of the biggest incubators in Belgium. So that's how we started the company in 2020, roughly, where we did some research project and started building up the robot. So first up, let me introduce our robot. We actually call him the Autonomous Towing Robot 2 because it's the second one we have. The first one was our prototype, and we just build up on top of that. This is a more industrial version of what the conduct guys were talking about. This is pulling actually 600 to 700 kilograms with our base model, and up to, we believe, up to 2,000 kilograms with our newest and latest version. What we are doing is actually towing everything on wheels. So when you can attach a gripper to it and it has wheels, we can actually tow it. We have kind of different mechanism to support different carts. We use a rotating top plate and retractor arms to adapt to different carts. So it's not only a single cart application, we can adapt to specific carts, different widths, different calculations, and based on whatever we see from the robot, we adapt to that specific cart. Because we also have a new wheel, we designed this wheel ourselves. This is the omnidirectional wheel, also familiar from KUKA and other companies who already done it. But we use it as to optimize our movement and allow us to move in all directions with our base platform. Everything uses inductive charging. So we start by going to our base station, and then we just inductively charge just for safety because we don't have physical contacts. There's no sparking, there's no nothing. And we can actually also support in-road or in-road charging where the plates are actually mounted inside the road. So we can adapt and get bigger round trip times and all that to just get more users out of the robots. But we are not directly talking about our robot here. We are more talking about what is the framework that we are using and how we came to that approach and how we started using the Zeno platform or the Zeno protocol, sorry. So the warehouse and logistics solution that we started building this in 2020, very early 2020 when ROS2 only started and was not very stable. So we envisioned a big architecture where we started from the robots running ROS2 and then going up in each layer of the network, going to the edge where we talk about getting all the data from the robot and not blasting the network with everything, then going into a management layer for the fleet that we actually direct robots to go to, that we have a warehouse management system, talking to the fleet, orchestrating tasks where they should go to, which carts to fetch, and then eventually where he needs to pick it up and drop it off. So the top layer is then once you get into the cloud environment where you have more predictive maintenance, anomaly detection, that you aggregate all the data of your entire fleet and then start making good assumptions about it, like saying, yeah, your wheel needs to be replaced because you've been driving it for 25 kilometers. So in the beginning of 2020, this was, of course, not when Zeno was really there yet. So we were looking for a solution, and we started a research project with Fed for Fire and the European Commission, which was called a Robotics as a Service bench, which we benchmarked over ROS2. Because ROS2 was quite new at that time, I think we started with Crystal. So then it was not that stable, but we actually started a research project to see how well it would scale over a wide area network. So the project itself had a couple of ideas where we had multiple sites of customers, then multiple customers actually all talking over ROS2, in this case actually talking DDS, communication traffic, over even a VPN to different global enterprises and then different sites globally, talking to a cloud infrastructure that we had set up for ourselves. This was also, it had also be deployed on a Fed for Fire system, which helped us actually scale these things. Fed for Fire has some test beds which are in the States, some in Europe, some in Asia, and then we can actually orchestrate deploying multiple sites, multiple customers, and actually scaling our virtual robots across these platforms. We developed a tool for it, which actually can orchestrate the setup with these test beds. And then we could quantify or set up some parameters, like, for example, do we use SROS, like the security level of ROS2? What quality of service settings do we apply on each subscriber and publisher? And then we can also throttle each link between sites, links between the VPN that we actually are going to throttle or introduce latency in the network and all these kind of things. Eventually, this tool never got released to the public because it got changed so much and the testbed itself is not fully free. And we found that in the end of the product, ROS was actually giving us quite some problems. Like a lot of presentations shown before me, in the beginning, ROS2 had issues with scaling. So during this project, we actually tried scaling from one virtual robot to 200 robots, but we got already stuck at 40. And in that time, every robot, in our case, had roughly 10 nodes. If we would adapt this to our current robot, currently we have over 50 nodes for our single robot. So as in that state of ROS2, we wouldn't even be able to run our single robot connected to one of the other sites. Like, okay, our site was not local. It was running through a VPN over to a European center. I think it was located in Spain. So there was some distance, but we found out that even just the local Wi-Fi network was causing a lot of issues. What we did with this tool is actually test different RMWs. Initially, when we were using dashing during this report itself, the default version was FastDDS. And we saw that FastDDS was actually a lot worse in performance at that time than, for example, Cyclone. Cyclone would scale a lot better with more nodes. The discovery process was working a lot better. But still, we were hitting limits like once you reach 40, 50, 60 nodes. Then again, what is also very important for us is the latency of these messages. If you want to control your robot to a teleoperation, you don't want to have a latency of 200 milliseconds or if it's really that it's a consistent 200 milliseconds, you can handle it. But as you see on the right bottom picture, it's actually fluctuating very a lot between different runs. So it was not consistent and we could not make it work. So it was not the end of tractonomy, of course, but because we are still here. So we started looking for a solution. And that's also when we came across some nice guys from ZettaScale currently. But we first started adapting a bit of ROS2, because in 2020, there was not really anything from Zeno yet as to the public. So we started by limiting the ROS2 traffic based on domain IDs, or even literally saying that you were losing the local host network adapter. That was providing us with reducing the number of ROS nodes which were actually published over the network, but we would still see that once you scale up to 20, 30 robots, you have the same problems. So eventually the solution actually was Zeno. We started using the Zeno DDS bridge early or mid 2021. I believe so. It was a very early version of it. Bleeding edge. Yes, we were even using the master version of it. So we didn't even see the tagged versions yet. But at that time, we could already operate just the default stuff. Just pops up like the topic, subscribing to it, see information. And we started using it for getting heartbeat messages to our infrastructure, seeing where the position of our robots are, and all those kind of things. So we started including a Zeno router or Zeno client with the Zeno DDS bridge into each robot. So eventually the goal was to adapt that early architecture that we designed into this concept. And we actually exploded the use of it by including multiple Zeno routers in each site of a customer. And then for each customer, they would aggregate their sites and then have multiple customers. So we aggregate those again. And then you have in our cloud also a Zeno router, which connects directly to the robots. And we can route everything to Zeno. What helped a lot by using Zeno here is the plugins. Because we can actually scale and adapt our own knowledge of Zeno stepwise. We first started adapting our robots themselves. It was just plug and play. Everything worked out of the box. And then now that we can think of improving the performance once we go to the cloud, we can start removing ROS plugins on the cloud side to the Zeno API. That would help performance, and then we could actually also use a lot more of the wildcard support of Zeno instead of all relying on the ROS2 specific knowledge. So this helps us in a good way, because now you can actually also monitor each robot individually from anywhere in the world if you connect to our cloud infrastructure directly to the Zeno router running in the cloud. But we can still, if you have access to the subnet, directly connect to the robot if you want to have more access to it. So we split up our access based on scoping. So instead of using different ROS domains, we scope actually the Zeno DDS bridge. And that way we can limit also which topics and which actions and services we supply to the public, helping, for example, customers who don't want their data to be public or transferred to a cloud. So here is a small demo of the current design of a robot and how he's working. So this is a very short demo, of course. This is running at a customer of ours. It's just adapting to the cart. The retractor arm comes out, and he's seeing the tag, and then he's going closer. We already did a lot of improvements on this system. It's, of course, a work in progress. We've been working on this currently for 3 years. We're almost hitting the 4th year, but we will be starting adapting to more of Zeno because we see that it's actually helping us quite a lot. So I hope you enjoyed my presentation. My name was Elias de Koning, and I'm actually very glad to be here.
Thank you, Elias.
Thank you, Elias.
Thank you, Elias.
Thank you, Elias.
Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank you, Elias. Thank And as for the other speaker, please keep an eye on the social
Yes, I will.
media, because question will be there. Thank you
Thanks.
very much. Okay, so that's like a marathon. We're almost done with user presentation. And next one is Professor Hideki Takase from University of Tokyo, which, as I was mentioning in my intro, will be talking about the use of Zeno in combination with the Elixir programming language. So let me just... okay, so as Hideki is based on Japan, he was so kind to, and it's really late for him, he was so kind to share a video with us. So I'm going to share the video with you guys. Okay. Okay, I need to, and in fact, I need to quickly switch to Chrome then. So let's do that.
Hello everyone, or bonjour, or konnichiwa. My name is Hideki Takase, an associate professor at the University of Tokyo in Japan. And Shintaro Hosowa is a project researcher in my laboratory, and he is my best research partner. Thank you so much for inviting me as a presenter at the Zeno user meeting 2023. But unfortunately, this event is going to be held at midnight in Japan. So please allow me to present this video recording. Our talk title is Zeno meets Elixir in Japan. We hope you enjoy our talk as one of the examples of research activity for Zeno. Before talking about Zeno, let me talk about robot operating system. We have already established some achievements for the growth of ROS ecosystem. One of the successful projects so far is MROS2, the integration of embedded technology into ROS2. However, we don't have a plan and project already established some achievements for the growth of ROS ecosystem. One of the successful project so far is MROS2, the integration of embedded technology into ROS2. However, we don't have enough time to share this activity in this presentation. So please check our video archive at ROSCON 2022, held in Kyoto, Japan. Second project is RCLEX, a new client library for the functional language Elixir. I will introduce this achievement as the first topic. During this research, we met Zenoh, and then we decided right away to adapt it for our research project because Zenoh has a perfect feature to meet our requirements. We will also share this later. Finally, I will introduce the ongoing activity. Can you imagine that what happens when Zenoh meets Elixir? Okay, let's go to the first topic. As we know, ROS2 has an awesome software structure. The most important component in ROS2 is DDS. The RMW layer is on top of the DDS layer. We can choose a suitable DDS implementation by changing this layer. And of course, we were too surprised and excited when ROS2 TSC announced that Zenoh would be a new target for RMW support. But please focus on RCL layer for now. ROS client library provides common features for ROS2. This layer is implemented in C, so we can implement a client library for any programming language by calling this C layer. So what we need is RCLEX. RCLEX will bring the power of ROS into the Elixir application. And more, we can implement ROS node with Elixir by functional paradigm. By the way, do you know Elixir? I think Elixir is not very famous in ROS and Zeno community. Elixir is a functional programming language operated on ARM virtual machine. And ARM has been developed by Ericsson from 1986. One of the key features is that the processes in ARM is very lightweight and robust. Moreover, since ARM has been developed for telecommunication and server systems, it has excellent concurrency and parallel performance with soft real-time capability. So we can construct distributed and fault-tolerant systems in ARM. Elixir inherits all these advantages of ARM. In addition, Elixir and ARM are very similar to the actor model. In the actor model, actors send and receive messages in parallel to realize concurrent processing. All messages are going to be exchanged asynchronously. Since the actors are communicated only through the message, we can also realize loosely coupled systems with ARM and Elixir. In addition to features inherited from ARM, the notation and specification of Elixir is designed based on Ruby. So the notation of Elixir is easy to run, and the productivity of application becomes very high despite functional. This is one of the example code in Elixir. This code generates a list from 1 to 1000, distributed the list element to each core, applies the function foo and bar to each element, and finally returns the result to the sorted list. I think programming should be about transforming data. I'm happy if you agree that data flow and parallel processing can be described directly by Elixir. Furthermore, Elixir already has a strong ecosystem with many libraries and frameworks. Phoenix for a web framework, Nerves for IoT application, Ect for database management, and NX for AI ML application. This means that we have the perfect environment to start developing IoT systems in Elixir. And more, we want to integrate the power of RCLEX into Nerves platform. Nerves is a dedicated platform for IoT devices developed and maintained by Nerves project core team. Nerves offers fully compatible features with Elixir. and also nerves provide useful libraries suitable for IoT systems. There are two important points for nerves platform: bare minimum and resilient. Bare minimum means that the firmware of nerves is too small, around 30 megabytes. The nerves compiler links the embedded Linux kernel, libraries, and application code together as one firmware. Resilient means that the nerves platform is robust and reliable. Of course, we can realize highly robust systems with the power of ARM. Moreover, nerves firmware has a unique file system structure consisting of duplicated regions. The kernel and applications run on one file system side, but if a failure occurs there, we can migrate to the other file system and continue the operation. Here is a list of supported target ports. We confirm the operation on RCLEX on nerves so far. And this table shows the support of loss distribution for RCLEX on nerves. Raspberry Pi 4 with Humble is the best to try it out. We also support AMD Xilinx Clear KR260 ports, BeagleBone boards, STM32 MP1, and ERT3 Plus. Now, I want to show the demonstration of RCLEX on nerves. We use Raspberry Pi Mouse P3 as the mobile robot. RCLEX on nerves is installed on the Raspberry Pi 4 mounted on the robot. The USB camera is also mounted on the Raspberry Pi Mouse. We know that we can control the robot by publishing the CMD bell topic from joypad, and we can also subscribe sensors on Ubuntu Roast laptop. But this alone would not be interesting for RCLEX on nerves. Yes, let's integrate the power of the Elixir ecosystem. We also implemented Phoenix LiveView web server to monitor sensor data via HTTP access. This is a recording of demonstration. The left side is a robot's actual behavior captured by the laptop camera. And the right side is a Phoenix LiveView web page operated on the robot. We can confirm the sensor value easily by such a web page. And also, please imagine that such IoT applications can be easily realized with the magic of an Elixir ecosystem. By the way, what do we really want to realize in our project? We want to connect any nodes in widely distributed environments easily. Please imagine that two computers are in same network and they know each other's IPs. In this case, Elixir offers Node Connect feature to connect them in the network. Node Connect is very useful, but we always specify node name and IP address to each computer. But please consider the case where you don't know the computer's IP address in the network. How can we connect with such a node without its IP? Actually, our RCLEX can resolve this situation. However, in the next case, we consider connecting a node on a computer in another network. If the computer has a global IP address, such as server, Node Connect works fine to connect them. Also, Node B1 can connect with Node B0 because they are in the same network. However, do you think Node A1 and Node B1 could connect as nodes? The answer is no. We could not connect them because RCLEX and DDS have a limitation about NAPT server. The final concern we want to realize is communication with Node A3 and Node B3. These computers are on different networks, and of course they don't know each other's IP address. In such a situation, we want these nodes to communicate easily. Yes, we have RCLEX for the same network and Zenoh for the different network. Zeno is a perfect solution to meet our requirement. So we try to integrate the power of Zeno into our RC on NAVs platform. We came across Zeno around June 2022, and then ROSCON 22 happened in October. We found the ZettaScale booth and we could meet Julien and many of the folks and got to know Zeno deeply. Zeno can construct any topologies, is extensive to other protocols, runs everywhere, and there is a plugin for DDS. And 2 weeks after ROSCON, we had a plan to present RCLEX at CodeBeam America, one of the famous conferences in the Elixir and RM community. We decided to try Zeno for our project. In just 2 weeks, we have established a way to integrate Zeno into RCLEX. Just 2 weeks. Amazing. Well, the solution to how to use Zeno with RCLEX on NAVs is summarized in our repository. Since Zeno is implemented only in Rust, both routers and clients can run only in statically linked binary. To run Zeno's bridge for DDS on a computer, we simply specify the router's IP and port number as arguments and run it in the background. To operate this on NAVs, we turn to use of Muon-Trap approach. This is one of the features in NAVs to allocate the executable to be run as a daemon. Please watch the video recording of a live demo at CodeBeam America. The entire presentation is available on YouTube. Now, these two computers can connect each other, and joystick value, I can control the behavior of turtle by joystick value. This is the first demonstration. And for the second demonstration, Zeno is up for grabs. We have a Zeno router running in a VM deployed on Azure. I will control the turtle nodes running in Japan by using the Zeno DDS plugin. This means that RCLEX message between nodes will go beyond the Pacific Ocean. So it's time to demonstration. I want to introduce Shintaro. He's a project researcher in my laboratory. So what time in Japan?
Okay, good morning, everyone. I'm joining from Japan. Okay, I share my screen.
Maybe Japan is around 8 a.m. So I guess he may be a little angry to help with this demonstration so early in this morning. So please share your screen, okay? I got it? Yes. And there are 3 terminals. In the first terminal, he is connecting to Azure VM and launching the Zeno router. And in the second terminal, Shintaro is running Zeno DDS plugin on his laptop. Of course, I don't know the IP address of his laptop. Now, please bring up the turtle sim node on your laptop. Okay. I execute 2 commands again and operate the joystick. Can you hear? Can you see? Oh, okay. RCLEX message go beyond the Pacific Ocean now. Thank you very much. Okay, thank you for watching. We can now confirm using Zeno along with ROS2 DDS and Elixir. But please remember that Zeno runs everywhere because there are native libraries and API bindings for many programming languages. Oh wait, there are no Elixir. The answer is yes, we can. Here is our latest activity to establish the marriage between Zeno and Elixir. We are now working on the development of Zeno EX, Elixir API for Zeno. Key idea to realize Zeno EX is very simple. Elixir and RM provide a nifs feature that can call the function implemented by other languages. We use Rassler as a nifs feature. Rassler is a famous library to call Rust function from RMVM. It can call Zeno APIs and convert RM and Rust resources to each other. Of course, our source code is published on GitHub. Please check it out. Now, it's demonstration time for Zeno EX. Create a new Elixir project and add Zeno EX library in it. The left side is a subscriber code. This node will create a session to subscribe the topic and then execute callback function. The right side is a publisher code. This node also creates a session and publishes a string message repeatedly every 1000 milliseconds. Now we will start both nodes. Subscriber and publisher. Yes, we can confirm that these Elixir nodes can communicate by Zeno protocol. Of course, Elixir nodes can communicate with native Zeno nodes implemented in Rust. Please understand that Zeno EX is still in an early stage of development. Supported feature is very limited and there are many works to tackle. We would be happy to receive contributions from you. Just FYI, I wanna share 2 upcoming events. First, we will present Zeno EX at CodeBeam America, which will be held next March. In order to make Zeno more widely available to the Elixir and RM community, we should work hard to improve Zeno EX features by the time of this conference. And one more thing, we are very happy to welcome Angelo in Japan. If you are also in Japan next week, please join us for this meetup. Please find my account Takase Hideki on X, GitHub, and Discord server for Zeno. And feel free to contact me to ask anything and give your advice on our research topic. Finally, thank you very much for watching my presentation. Merci beaucoup, or in Japanese, ありがとうございました。
Angelo, I cannot hear you. I'm not sure whether that's on my side or yours. Can you hear me? No?
Okay, now you should be able to hear me. Can you?
Yes, now I hear you. Can you hear me?
Yes, I can. Great.
Okay.
Okay, very good. Okay, so Christopher, what I was about to say, well, thank you for holding on. How does it feel to be, dulcis in fundo, last but not the least, our last presenter of the day? So quick intro, and then I'll let you go through your slides. So Christopher Elpa from TT Tech, one of member of the innovation team that is part of the city office, and essentially performing research in the context of automotive software. Your screen is showing, so you can share your slides. You can go on presentation mode. The floor is yours. Best of luck with the presentation.
All right, you see my slides, right?
Yes, I do.
All right, awesome. So thank you very much for the introduction. I'm really glad to be here and talk about ZenoFlow, another exciting technology from ZettaScale, and also how we are currently working with ZettaScale to add additional features, which we think are very critical for autonomous driving applications in general. So before we jump in, let me briefly explain you what we are focusing on. So autonomous driving is a huge domain, and as a company, we focus on safety aspects. So what does this mean, right? I mean, safety is the domain of ensuring that the system is working in a way that no one gets harmed. And there are multiple things to do this. First of all, when you develop your application, you need to ensure that you're building the right thing. So when you're building an autonomous driving application, you need to design it in a way that it works in our driving scenarios, that it works in our environmental scenarios, that it detects all the obstacles it needs to. So this is basically making sure that you're building the right thing. This is something we are not focusing on. So as a company, we are a platform provider, but we are providing a platform so that autonomous driving applications can be hosted. The second thing in safety is ensuring that you're implementing it right. You need to show that you are sufficiently free of design faults, right? So this has two aspects of it. First of all, the function must work correctly. You must show that what you have implemented just works and does what it is supposed to do. But the second thing, and this is one thing that we focus on mostly, is it needs to fulfill timing requirements, right? So an autonomous driving application interacts with the environment. It needs to react to things, and it needs to do this in a bounded amount of time. Otherwise, the output it produces, like steering or evading objects, is useless or even harmful. And in general, it is not possible to prevent all faults and all bugs. I mean, software development is complex. It is not possible to write bug-free code. So you need a second layer of defense. So you need to monitor the system and react accordingly if something goes wrong. And lastly, you must show that all of this is working as intended. So you need to validate it. You need to argue that the system is correct. So in our domain, for software development, this means you need to follow some safety standards. And in our case, this is the ISO 26262. And this basically tells you need to have a proper safety design. You need a top-down waterfallish process to ensure that you are really building the right thing and you are building it the right way. And there they mandate some design patterns. You need to avoid error-prone solutions. So take simple solutions, proven ones, build a deterministic system. So really see that you get what you want, right? And you're not surprised by randomness, which also means you should prevent dynamic behavior as much as possible, because then you introduce possibilities for race conditions and things like that. And if you do this, you get some nice properties out of this. So first of all, you will have designed a system that is easy to analyze, to review, to argue that it is correct. It will be simple to test. If it's a deterministic system, the tests will be reproducible. You don't have too many complex testing scenarios, and they have a high quality, and they can show that it is working as intended. And all of this you can then put into some safety argumentation. So basically you propose a way, so you explain to someone, it's a bit more complicated than that, but You can imagine it like this. You pull together all of your evidences, what you did, and argue that the system is safe, and this should be easy to understand. You cannot have very complex arguments that no one can follow, so this should be simple to do. So what do we do as a company? So we are a software platform provider. We have like two main products. One is MotionWise, which is based on adaptive AutoSAR, which is a whole platform which provides certain properties to the system. So it is predictable, it is real-time capable in the sense that we provide real-time capable scheduling mechanisms. It's scalable and things like that. And it provides features like state management, health management, safety supervision, as well as communication and time synchronization. The other one that we are working together with ZettaScale is ZettaAuto, which is a safety certified DDS stack. So again, we're not doing application development itself, but we provide basically everything that an application developer needs to implement and integrate their applications into the system. But we need to follow certain architectural patterns. We're not free to design this in a proprietary way. The automotive industry settled a few years ago on providing a standard for software architecture and the whole ecosystem. The goals for this are clear. You want to have interoperability. You want to, as an OEM, be able to easily integrate applications from different suppliers. You want to be able to exchange suppliers. You want to be as agnostic from proprietary things. And for the software suppliers, of course, it's helpful to implement a standard because it will fit into any OEM. Historically, this comes more from the control things. So there was before classic AutoSAR, which is really focused on embedded hardware. So really focused on control algorithms and things like that. This changed a bit with adaptive AutoSAR. It's more focused on general application development, but it still inherits a very, it's an approach that is very heavy on configuration. So the main problem was always how to configure the overall vehicle, how to integrate applications which are quite simple, but you have a whole car to configure. So you want to handle how to deploy them, how to configure them. And this workflow was carried over to some extent. So there's lots of configuration aspects. You need to define your applications. You need to define services. You need to define interfaces. You must map them together. You must design the specification of the machine. You need to deploy them. And all of this is following this idea of having everything offline, having everything as human readable things, and very little code. So software development in this flow is only this small box up there. It's all about configuration. It's about generating things. This is good for the integrators and the safety engineers because they do not need to read code to argue about what is going on. But for developers, this is not so ideal because whenever something needs to be changed, a new interface added, a deployment changed from one host to another, they need to go to this world they don't really know too much. You need maybe to go to the integrator to change things. So software development is relatively slow. And for autonomous driving, this is a bit of a problem. So one salvation, or is it a salvation, would be to go more to developer-focused things, like, for example, ROS2, right? There, it's awesome. It works well. You can easily build something. You can get something up and running pretty fast. It's easy to configure. Not much configuration needs. Not a lot of tools. Everything is code and everything is dynamic and it just works. So developers love this because they can get their application up and running fast. But integrators and safety engineers are not so happy about this because they might not be developers. They're not focused on being able to read code. Finding this information that is critical is hidden somewhere. So that's not so good for them. And lastly, so from configuration, all of this is fine. And lastly, one of the aspects I already mentioned is from functionality perspective, we need to ensure that we produce outputs in a given amount of time. So there's always this model of autonomous driving where you sense something, then you do sensor processing, fusion, path planning, control, and then actuation in kind of this chain, right? And what you now need to argue is that this happens in a bounded amount of time, so fast enough before you crash into the overall system. But the problem is that this is kind of a model that does not really hold. In reality, this processing chain is a complex graph of lots of interacting components. So what do we now want, and why is Zenoh flow interesting here? So first of all, we need a mix between this flexibility that developers really want and this offline analyzability to make the integrators and the safety engineers happy. It needs to be balanced somehow. It's not A or B, because you're just shifting like the niceness from one persona to the other. We need to find a balance. We need predictable end-to-end latencies of this overall processing. We need a very deterministic execution. In our case here, we're going for data flow determinism, and we need to control when something is not working as intended, right? Dealing with temporal aspects where also scheduling is involved is always hard, because software developers are not used to this, right? When you develop software, mostly you're taught you have as much hardware as you need. It just runs, and as long as it's not lagging, it's fine. That does not work for real-time systems. We need to really focus on getting the timing right, but this is not always possible, and therefore we need to control the system in a way that is still safe if something does not match what we expected. So Zenoh flow provides a data flow programming framework. So what does this mean? When you design your application, you model it in a directed graph where we have flow of data between operators. So you can see this like this. You have this source operator that provides some data, which is then operated on by this operator B. He passes it on to C and so on. So the data flows through the system in a way that it triggers the computation, new outputs are produced, and then it goes on. So Zenoh flow allows to express this explicitly, and you already see, if you compare this to before, where we had this complex processing graph, this looks quite similar. So how is this done in Zenoh flow, and why is this a nice approach that could balance this offline configurability and the flexibility? In Zenoh flow, you describe your data flows. So you describe the nodes that are involved, your processing elements, the data names that are exchanged, and the links between them. So if you take this example here, so you define your camera. Your camera is your source node. It produces some output. And then there's another operator that does something. In this case, it's a facial recognition one that has some inputs and some outputs, and then you can link them together. So you say, okay, camera produces the output stream. This is mapped to the node facial recognition, which considers this his input. And with this, you define the overall flow through the system. So this is nice because this is a human readable format, but it specifies the whole processing. So you can analyze this offline. You do not just need to run it and then produce something like an architecture graph in ROS2 where it tells you how the system interacts, but you get this upfront and you can analyze this upfront, whether this makes sense or not, and the system will just behave exactly like that. And finally, you have a mapping of where the nodes run, so you map your nodes to some compute elements. And this allows us now some extensions that we are currently working on with ZettaScale to add. The first thing is you can now take this graph and control the execution through the graph. So you take this input definition, you build up your whole graph, and then you know if a certain node finished, which ones are the ones that should execute next. So if you see here the first one finished, you know that 2, 3, and 4 could be executed because they only depend on data that is produced by the first node. If you then go on and say, okay, you have finished the node 4, you can look again at the graph, but then you see that you cannot yet dispatch this node 8, because node 8 also depends on the inputs from 7 and 3, but it did not run yet. If this had been a purely data-driven system, like in ROS, for example, operator 4 would just produce the data, which would cause an interrupt at node 8. It would run, do something with the data, figure out it should not run yet, and go to sleep. So it would be woken up each time new data arrives, which leads to overhead, indeterministic behavior, race conditions, and things like that. And you need to handle this as an application developer. In Zenoflow, if we have the guided execution, we will only dispatch it once all of the data is actually here. And now we can add scheduling and real-time behavior traits. So we have this graph, and if we annotate our nodes with timing requirements, time and budgets, or timing contracts, if you want, we can analyze what the overall temporal behavior of the system will be, and you can control the dispatching in a way to optimize the system. So just briefly here, those two examples. If this first node is finished, and we now know that 3 nodes could execute, but we only have 2 cores, then we need to make a decision on which of those 2 nodes we want to execute. If you don't control this, then this will just happen due to race condition. Whoever is triggered first by the scheduler will run first. But thanks to Zenoflow, we can do better. And we already see, I'm not going through the whole trace, but just to illustrate the point, if we dispatch nodes 2 and 3 first, we will get an overall latency of 40 milliseconds. However, if we decide to dispatch 3 and 4, we will get only 50. Why? Because in the second step, the only node that could be executed is this node 2, because nothing else is ready. And therefore, we are not utilizing the CPU efficiently, because 1 core will go idle, and therefore the overall execution time will be longer. So we have all this timing information available, these timing contracts. We know the graph, so we can introduce data flow scheduling into this. So we can really analyze the graph offline, take this timing, run some heuristics. Scheduling is NP complete, so we can never find an optimal schedule, but we can run some heuristics that optimize the critical path. So we can, thanks to the data flow graph, basically see into the future. Whenever we dispatch a node, or when it finishes, we invoke the scheduler, and it can look at what has already executed, what we need to execute next, and which will be the best node to execute in order to have the lowest overall latency. So we do this at runtime whenever a node finishes. So this means also that we can tolerate that nodes don't always use up all of this time. So it might just finish. If this were a fully offline generated schedule, we could not do this, but we do this dynamically at runtime to take this into account. And last but not least, we said that we need to control when something goes wrong. So those nodes have those timing contracts to say, okay, normally I should just finish in 10 milliseconds, and the system is designed for exactly this. However, it could of course happen that it runs longer for whatever reason. If this happens, we would not be time deterministic, because the whole processing is delayed. It takes longer than we thought it would. But you might want this during early development when you want to test things and see whether the functionality is up. That's fine, because it's data and data flow deterministic. You always get exactly the same. But when it's running in the real system, you might not want this. You want that it reacts in 40 milliseconds. It's acceptable that the output is not ideal, right? So you can tolerate some data loss. So what we would do is, if the node violates his timing contract, we stop it. But for the overall processing, we just go on. Meaning, if eventually those nodes 7 and 4 finish, we will still dispatch node 8. This means that he will not get the data that 3 produces. It needs to be able to deal with this. And the output will not be exactly the same as normal, but you're still guaranteeing that you're producing an output in this 40 milliseconds, which means you're still evading an obstacle you might have detected. It might not be the ideal maneuver, but you're still going to be safe, and this is what we're striving to do. We're also working currently, ZettaScale mostly, on how to add prioritization for mixed criticality, that you can have multiple of those graphs at different priorities, core pinning, and other things to optimize the system further. So to sum it up, from our perspective, as I said, we need a system that balances the needs of both the integrators and the software developers. We cannot do all of this complex offline configuration because it slows down developers, but we cannot do nothing, right? We need a balance of this, and Zenoh provides this thanks to the overall architecture configuration that it adheres to at runtime. So this looks like it provides a very good balance of those aspects. It allows us the data flow deterministic execution, and with the scheduling, we can optimize the overall end-to-end latency, which provides you additional performance benefits, and we control when something does not conform to this contract you have to ensure that the overall execution maintains safe and we fulfill our real-time requirements. So this is it. So thanks for your attention. If there are any questions, I'm happy to take them.
Thank you very much, Christopher. Questions will be asked, are being asked on social media, so please keep an eye on LinkedIn, Twitter, or YouTube. That's where the comments and the questions are going on. Thanks again for taking the time and sharing your experience with Zenoh. Let's thank, obviously. And
thank you for having me.
Yeah, our pleasure. So Luca is next on what's next, right?
Exactly.
Okay, thank you again. So we'll get back now to the Zenoh team and sharing. No, there is no break, guys. Why? So they wanted a break. I mean, I can't believe. We're almost done, guys. No, there is no. We're unbreakable, aren't we? We're worse than Djokovic, right? Unbreakable. Okay, so again, impressive series of user told this year. I think compared to 1 year, there's been an incredible progress. So very proud of that. So Luca, what's next on Zenoh?
Yeah, so hi everyone, I'm Luca Cominardi, I'm the head of technology here at ZettaScale, so I'm leading R&D activities for Zenoh. So what's next? So we have seen what people have been using Zenoh for, but there are quite a few activities that are already going on in Zenoh. The most important one, I would say, at least as a flagship activity, is we are targeting the release 1.0.0 for Zenoh. And this we are targeting as a graduation release for Zenoh as part of the Eclipse. And we are targeting this release for Q1 of next year, so 2024. So this is going to be a huge milestone for Zenoh and for all the users, I believe, that they're using Zenoh, because help us validating the maturity of Zenoh, as we have seen today. And this graduation release from Eclipse will really give us the official stamp from release that we are out of the incubation phase and we are a mature project. So we are working hard for that and expected this to happen in Q1 2024. Next to release 1.0.0, we have been working on quite a wide set of features. So I'm just going to through to some of those here today. So those are features that are not ready yet. So we are working on that. We got the team that is working on that. And one of the features that has been requested many times is access control. So we already have, for example, through the bridges, some sort of access control, right, to allow to deny certain topics like expression that can be exposed from, for example, over the cloud, etc. But this is not a generalized behavior for Zenoh yet. And we also want to go beyond just a whitelisting or blacklisting of this expression, but to have some kind of access control based also, for example, for some identities, for example, based on certificates, or for example, with some token. This goes beyond what we already have as of today, that is TLS mutual authentication, as presented at the beginning of this meeting by Angelo, or for example, user password authentication, that those kind of access control are all or nothing. So we want to provide now, and we are working on that, to provide fine-grained access control per key expression. So another important work that is going on in Zeno, that we are porting the full Zeno implementation from Async SDV to Tokyo. For the people who have been more familiar with Async SDV at Tokyo were, basically there were two types of async runtimes and frameworks that were fighting. Let's say that they were fighting for the leadership position a few years ago when we started doing Zeno. And for performance reasons, at the time we went for Async SDV. That's also one big kudos for the performance that we have got in Zeno. It's also thanks to Async SDV. But apparently the full ecosystem community now is moving to Tokyo. And Tokyo has matured well enough today, also in terms of performance, that we carry on a re-evaluation of those frameworks that happened a few months ago. And Tokyo now provides the same level of performance of Async SDV, with additional benefit of having a full ecosystem that is developed by the community, like telemetry, tracing, profiling, etc., etc. So there is ongoing effort. We are moving Zeno from Async SDV to Tokyo. I expect this to be in for the next release. Then we are working together with other partners. For example, just naming two presenters today with Intrinsic for Rust and new protocol with the GM, how to improve shared memory support. So shared memory is already available in Zeno. We got, thanks for new use cases requirements and some rework that we are doing with the protocol, how to improve shared memory compared to what we already have now. So we're planning to have an improved shared memories that we can support more topologies, more use cases, and as well as to have a more out-of-the-box easy experience for shared memory as of today. Then we are also working on a JavaScript and TypeScript API. This is in the making here. It's quite small. I don't think that you can easily see, but this is just a code snippet of what's going on for JavaScript and TypeScript API that will allow to have Zeno also in the browser. So the goal that we have for Zeno is to be able to compile Zeno in WASM and to have an API, a JavaScript and TypeScript API that you can use in the browser. So native Zeno experience also in the browser via WASM. And what we are compiling to WASM is actually Zeno Pico via mscript and support. Then we are progressing and continuing the support for Kotlin, Java, and Android. We already had first support for Kotlin and Android. We want to make it more solid, right? So move it out from the alpha version, experimental version that we had. And we are introducing Java support as well, okay? So native Kotlin support and native Java support. This is one of the features that has been requested quite a lot from users, okay? That is, what if we've got my big payload that I'm transmitting, and I want just to attach some metadata to it. For example, if you are in performance-sensitive applications, you don't want to reserialize your payload. You want just to attach to your data some metadata you want to carry over and to retrieve it on the other side. And that's what we call the user attachment. So we are quite advanced in this feature. We are going to provide initial support for user attachment for Rust, C, and C++ first. And then we are going to provide also the support for other APIs like Python and Kotlin and Java, for example. Then we are reworking our plugin management system. Okay, so last year we heavily focused on stabilizing the API, the user API, so the API that you use to declare subscriber, to write data, to subscribe to data. But we didn't stabilize yet the plugin API. Okay, so what was going on now with the teams that we are stabilizing the plugin management API in such a way you can also write your plugin in such a way that it can expose its actual status. For example, to ease the management when you have it in a platform, or to know, for example, more fine-grained status for the plugin. And as part of the protocol improvement that we are doing, one important point is that we are also improving the routing in the sense that we are going to optimize even further the overhead that you can have over the network, specifically for clients, and specifically again for embedded devices like with Zeno Pico. So we are targeting as of the second batch of wire breaking changes that we're doing for the protocols, also take advantage to introduce some improvement on that respect. Then something that you are is MBFT reliability. It has quite a cryptic name, so this is been quite a debate here in the team how we want to call it. Let's keep it cryptic in such a way you are forced to understand what it does. So the idea is, let's have a non-blocking fault-tolerant reliability for end-to-end reliability in such a way that is non-blocking. So I don't want to go into all the details here, but just the bottom line here, we're introducing a new mechanism for reliability in Zeno that is end-to-end, and that targets failures not only on the link per se, but also to be resilient to changes in the topology. And the last slide about what we are working on right now is to add raw Ethernet support specifically for Zeno Pico for embedded scenarios. So to work directly over Ethernet and to be able to send Ethernet frames that directly contain Zeno messages, such a way you can significantly reduce the overhead in embedded constraints networks, but as well, for example, to improve the compatibility and to be more friendly with some network scheduling, like what would happen time-sensitive networking, so TSN networks. You can tune what kind of key expression are mapped to what kind of parameters for the underlying network to ease the scheduling of the whole system. So with this, I finished the quick carousel of what we're going on. So I don't think that you have seen this slide yet. So if you're attending this this user meeting, you haven't started yet the Zeno GitHub repositories, please do it, because it's something that makes you happy.
Yeah, much happier.
Yes, much happier,
of course.
Exactly.
Okay, so lots of good things coming up. A few more that have not been discussed, of which obviously Cannes is on our wish list. We'll see what we'll do on that. So come, Julian. So I think it's also important to refresh and have a few highlights on some things that actually have been recently made available. And so let's just give Julian the time to plug his laptop. Yeah, it's completely tangled here. Yeah, here we go. Let's untangle it.
Good. So
okay, so
here. To share my screen now.
And yes.
Okay.
I still don't see. Oh, here we go. Perfect. Okay, Julien. So the floor is yours.
Thank you.
Do you need any help with your additional camera?
If you, for the demo, if you can at any time come here and
yeah, and then we'll enable the camera.
Yes.
Okay.
Okay.
I'll do the operator.
Perfect.
Okay, for free.
Thank you. So what's been happening this year with ROS, with Robotics and Zeno with connectivity? That's a hot topic, as you have seen in all our user meetings. Yeah, let me remove this. Okay, let's put this somewhere around if I can move it.
Never mind.
I cannot move it. Wow.
Okay, fine.
Well,
We like it that way.
Okay.
Never mind.
Never mind. So, first this year, we released a very first version of a bridge for ROS1 because still a lot of users are using ROS1. And this bridge supports Noetic, and it acts either as a ROS master. It's per configuration. You can start this bridge or this Zeno plugin for a router as a ROS master. And all your ROS1 node will connect to this master and communicate peer-to-peer with each other. But at the same time, they will bridge to Zeno, and then you can have the use case that we have at the bottom, which is integration with Zeno, with all the plugins that you can benefit from Zeno, or directly with Zeno applications, with Zeno Pico applications, and so on and so forth. Or you can also perform bridge-to-bridge connectivity so crossing NATs, crossing WAN, going to a router in the cloud, or whatever deployment you want in a complex deployment between various robots, all in ROS1. It can replace ROS master, or it can connect to a ROS master already deployed in your robot. So as you wish. And last year, we already had a lot of success with the DDS bridge for Zeno. A lot of users are using it, as you have seen already in previous presentations. But still, we felt that we can do better with a more tight integration with ROS2. Now, that's what we did a few months ago with a new bridge for ROS2, dedicated to ROS2, which provide better integration with the ROS graph. So it means also the ROS tooling is working far better. You can see if you have two bridges interconnected together, you can remotely see all the topics, all the services and actions from a remote robot through the Zeno bridges. And you can also have RVs working very well across Wi-Fi, across the internet, and so on and so forth. The services and actions are mapped now on Zeno queryable, which makes those far more easier to call from any Zeno application. Just do a get operation, and you can call a service, you can call an action, providing you give the correct payload encoded in CDR as usual. And we also improved a lot the discovery information between the bridges with regard to the previous forwarding mode in the DDS bridge. This mechanism leverage the liveliness tokens that are now also used in RMW Zeno, which is work in progress. And most of us, an interesting feature is configuration of ROS namespace directly on the bridge, meaning that you can keep your robot without any namespace, working locally without any namespace inside your robot, and the bridge on the fly, exposing all the services, topics, and action outside to Zeno will prepend the ROS name you configured directly on the bridge, meaning there is no longer need to configure each node in your robot. And what's next is, of course, the RMW Zeno that Franco and Yadu introduced just a few minutes ago. And that's work in progress. We are actively supporting this, providing some extension of feature in Zeno C. The target release will be in May, but we hope to have the possibility to test it and to make you test it sooner than May. And it's already reusing some ideas that we implemented in the Zeno plugin for ROS2, like the liveliness tokens for grass discovery and the queryable for services and actions, and also the publication cache and querying subscriber for transient local, and so on and so forth. And for this year, our goal will be, of course, to follow and support this RMW Zeno, but also to adapt the bridge that we have to also work seamlessly with RMW Zeno. So in this sense, you will be able to perform integration between an existing system using RMW DDS and a new system using RMW Zeno. And the bridge will make sure that all the RMW DDS node will appear as RMW Zeno nodes in the other system. So you may have a seamless integration. So demo time. Here is what we can do with the two robots we have here. So
start the camera.
Yeah. So we have two Turtlebot 4 nodes, robots, which are just here. On those robots, I will deploy the bridges, each one configured with a different namespace, bot 1 for the first one, bot 2 for the second one. And on my laptop, I will start a third bridge with a slash as namespace. It means that on the wire, all the topics coming from bot 1 will be prefixed by bot 1, and the bridge here will still expose those as slash bot 1 with the bot 1 namespace on ROS2 environment on my laptop. So I can distinguish the two robots in two different RVs on my single laptop. And there is no mix of different topics, services, and action between the two robots. At the same time, I still can have a fleet manager application, not as a ROS node, but as a pure Zeno application that will just publish some twist message on the Zeno topic, which are here used by the two bridges. So with this fleet manager, I'm able to drive the two robots. So let's see how this works. So here I'm connected to, I will remove this. Here I'm connected to the two robots. So at first I will start a bridge on each. So we can see already that in less than 1 second, this bridge discovered everything that is running on DDS on the robot, all the services, actions, publication, and so on. Here I'm starting a second bridge on the second robot. And you can see in 1 second, it discovered everything. So now here I'm on my laptop and I will start the bridge without any namespace. What we can see here, you can see we have a mix of various declaration announcement of different subscription services actions by the two robots. And that occurs also in less than 1 second. So now in here, for instance, I can do a ROS2 topic list. And I get all the topics prefixed with bot 2 and with bot 1. And you can see there is a lot of topics, a lot of various topics by the two robots. I can also list the services, for instance. So you can see we have the service for bot 2 and the service for bot 1. So now with this bridge, everything is working seamlessly with regard to ROS behavior. So now let's start our RVs. I'm starting a first RVs connected to bot 1. And we can see already the LiDAR, which is showing up here.
And usually it's not that fast.
Usually, yes, if you are plain DDS for ROS2, it's not that fast. You need to wait several seconds or several tenths of seconds to get
it was
the feedback.
instantaneous there. Yeah.
But now here we get the second robot LiDAR working. The camera are not on yet because the robots are on dock. But let's now move the two robots with this Python script. So here I just have the Python script. That's the exact Zeno Python teleop script we provide in a repository Zeno demos. So if you want to use it. So now it's connected to the two robots. And let's go. Whoa. And you can see all the reactivity. We have the feedback from the camera. And still I can choose to drive only one. For instance, here, if I'm starting the standard teleop from ROS2 and just using /bot1 as a namespace, now I can drive only the bot number 1. And here it's based with the teleop from ROS2. It's not a Zeno application, while the fleet manager was just the Zeno Python script. So that's what already we can do with this bridge. You can see a very smooth integration of ROS2 with Zeno. And now the next step is from Gabriele that will show what we have next with regard to the Zetta platform.
Yes. Do we still need this?
Yes, he will move the robot also.
Okay,
we'll make this thing full
so
screen.
I'll continue to be the operator. Yeah.
Yes.
A mirrored operator, because actually I have to move in the opposite direction as the window is the stuff is mirrored. Anyway.
Okay, so I'm Gabriele Baldoni. I'm principal engineer for the PAS, and I will just give you a brief presentation of what you could do with the platform and why you may need it.
Great.
Oh, sorry, too fast. So everyone is happy about Zeno. I mean, if you have full presentation of everyone is happy about using Zeno, this is because it's actually solving some problems. But as we can see, okay, the real world is not just some demos inside the factory. You may need to connect things that go over the cloud because you may have your fleet management that gets data out of the robot, or you may want to control a robot across the world because you can have different factories and you want to be able to get data of the robot because you want to manage them. So if you want to do it, then you have to provision your Zeno infrastructure yourself, but maybe it's not your domain of expert and you don't want to lose time on doing so. So what we offer is the Zetta platform, because your use of time is working on your business logic, which can be, for instance, on the robot, not on the managing Zeno routers per se. So in general, if you have a decentralized infrastructure, it's not easy to manage. And if you have a Zeno decentralized infrastructure that wants to spawn across different clouds or across different regions, can be even more complex. Why? Because first you need a cloud infrastructure, and that's something you can just, let's say, opt in. Then you need to be able to configure and deploy this Zeno router, eventually automatically, in the case you need to scale them. Then you need to monitor them because, okay, you deploy them, but you need to monitor those states because that router has to be up. Otherwise, your robot might be unable to connect. But most important, you also need to deal with security because, okay, my robot are inside the factory, inside the local network, not connect to the outside world. Okay, fine, who cares about security? But if all of a sudden your robots are connected to the cloud because you want to get some metrics out of them or you want to be able to control them from fleet management, then you need to deal with security because your robot and in general, all your data needs to be secured. So the objective of the Zetta platform is to simplify all of this. So deploying the Zeno router should be as drinking a cup of tea. You should be able to draw your infrastructure in the browser, decide where to place different routers, and deploy everything. And essentially, all of this should be simple, just a few clicks, and without caring about security because we care about it. So we are able to provide end-to-end security for the user data and for everything that you connect. So the Zetta platform is our magic wand. So we take our Zeno infrastructure, we just couple with our magic wand, and we are able to deploy the Zeno infrastructure across the globe, meaning across different cloud providers, different regions, and also across on-premises infrastructure if you have them. Of course, we are able to monitor and inspect your data at any time if you need it. But if you want, because you can understand that for some use case, you don't want to connect everything on the cloud, but you want to be able to have this magic wand directly on your premises, that case is also possible. You can have the Zetta platform just to manage your own cloud infrastructure that can be just on-premise. So as we said, the Zetta platform is cloud independent, which means we can run on different cloud providers. So the most famous one are AWS, Azure, Google Cloud Platform, as well as on-premises. And on-premises can mean directly, for instance, on a laptop, like the one I'm using for presenting, or your own Kubernetes cluster, your own OpenStack installation. So it means that you can mix and match all of them, and also you can bring your own cloud, which means that if you already have, for instance, an AWS account, and you want to say, okay, look, I like the Zetta platform, but I want you to deploy routers on my AWS account, fine, we can also do that because we can understand that for optimization can be a good way to do it. So the idea is to have this cloud-to-device infrastructure that is automatically managed, provisioning, and monitored by the Zetta platform. And of course, everything has to be as simple as possible and secure. By secure, we mean end-to-end security, so we are able to generate TLS certificates if it's needed, but we know that there are some users that have already their own PKI, so public key infrastructure, that want to provide already certificates because, for instance, they are temporary inside the device, or they, for instance, in the case of IoT device, they are temporary inside the device, so we need to be able to also work with them, and that's also something that we can provide. So there's a different way of opting to using the security. By default, everything is secured with TLS. Everything that's connected with the cloud is secured by MTLS, and we also have the possibility to get certificates directly from the user if the user has already done. But what are the use cases of this? So simple one, I would say, the one that we have seen a lot on the slides is ROS or ROS2, robot to infrastructure communication. So this is something that is not new anymore. So we have seen a few presentations about it. Zeno was selected as the first Zeno DDS protocol to be natively supported in ROS. So there will be an RMW Zeno. And okay, this is fine. In the local area network, it will work fine. But what if you want to go out on the cloud? Then in this case, we will need to connect our robots to the cloud. And given that we have an RMW, so we need to go through the bridge, what better solution to just use the Zetta platform and create your own cloud infrastructure with Zeno? So because people that work in robotics, their expertise is robotics. They don't need to care about how things are interconnected, and that's actually what we would like to do with it. What we do actually and secure exactly. So essentially, imagine you have your robots. You say, okay, fine, my robot. I want to get a configuration from my robot that uses TLS that connects to this other router with this specific configuration. We can just do a few clicks from the Zetta platform, download that zip file in which it is everything you need. Take this zip file, put on your robot, and all of a sudden your robot is able to communicate with the Zetta platform securely. So we have a few examples of people already using Zeno. So we have Mission Robotics that is using Zeno Pico in submarines. And we have Tractonomy, from which we had the presentation today, that actually they're already using ROS and Zeno with the DDS bridge. So maybe you should use the ROS2 bridge, and then maybe also use the platform if you want to connect things end-to-end securely. Another use case from which I will say we had a lot of experience in the past is scaling DDS. So everyone knows that DDS works well in local area network. I would say symmetric local area network, like wired local area networks. But already in the past, already 10 years ago, we had a product that was able to scale DDS on the internet, so on the wide area network. And another use case for the platform using the bridge and the connector that we have is to scale again DDS application up to the cloud. Of course, scaling DDS, it's a complex. I mean, there is no simple answer on scaling DDS, because if you scale DDS, you may break some of its semantics. So that especially, so why is it difficult to scale it? Because there are few things on the way DDS was designed that doesn't really match with having something that goes on the internet. So it's the reliability, because everything needs to be discovered everywhere. The discovery that from as we can see from the slide, he has a big Go dependency on number of topics, readers, writers, square the number of participants, which means that if you have a huge DDS systems, it will be very difficult to scale it. And so what we decided, okay, we want to scale DDS, so we need to break some of its invariants while keeping the application to work. And that's what the DDS bridge does, and also part of what the ROS bridge does. So for instance, what we could see that if we have an application that is using DDS in the local area network, like we're seeing on the slide, in this area, we could just put a bridge, connect this bridge to our Zeno infrastructure, and all of a sudden, all your applications are able to get DDS data also outside of the local area network. Of course, if there are subscriber matching. And the idea is that all of these has to be transparent for the application. So you still deploy your application with the default DDS configuration we already have. You place a router or a Zeno bridge DDS in your local area network. You discover the other application, discover the application on the other side, and everything talks complete in a way that is completely transparent. Another use case is scaling MQTT. So as you may already know, MQTT is hub and spoke, which means all your clients are usually connected to a single broker. And the only way actually you have to scale it is place a big enough broker on the cloud, which, okay, is a solution if you have enough money to spend on machines on the cloud. But another solution could be, why not have small MQTT broker locally and then interconnect them? So that's something you can do with Zeno. You can have, you can have MQTT broker, let's say on premises or on the edge or on different clouds, interconnect them through Zeno, and all of a sudden all your MQTT application are able to talk between each other, and you don't need anymore a huge MQTT broker on the cloud or on-prem, while you can break it out in different regions. And of course, you can mix and match. You can have Zeno application talking to MQTT and vice versa if you need it. So moving forward, the idea is to further simplify in general everything that is about managing, monitoring, and deploying Zeno applications. So for the time being, we support deploying Zeno routers with plugins. We are going to support in the future also deploying bridges directly, so you can just configure them directly from the web interface, and also add more use cases, like I said, for certificates, for access control when it will be supported in Zeno. So in a way that the Zeta platform is your place when you want to manage a complex Zeno infrastructure. And I think it's demo time. So
let me turn on the camera again.
Yes, turn on the camera. So we have already the bridges that are running. And actually, let me show the platform. So as you can see,
the camera is up. The robots are there.
So need to redraw it. So this is the interface. So this is the interface from the platform. As you can see, I have a project, which is a Zeno deployment, this case. And this Zeno deployment is with two routers. Well, sorry, two routers on the cloud are the one, this European router, and the one that we can see on the list. So we have a router in Frankfurt, in this case in AWS, and a router in North Virginia, still with AWS. And then we have a local router, which is depicted in yellow, with this yellow kind of light color. It tells you that this router is local. And actually, this router is running on a laptop in this room. And as we can see, there are two things connected to this local router. I think Chrome doesn't like to draw the things. Okay, there are two things connected to this local router. I think we cannot see them properly.
Hold on, no. The point is this. Hold on a second.
Because we can see.
But that's on the house.
Okay.
Okay, just give it the time to hide.
Yes. Okay.
That's good.
So we can see this local router, and two cannot really see the lines, but I can show you there are there is 2 robots connected to this local router because it's the robot that we just tried. And this is the icon that tells us that those are actually peers. And we can see also that all the links are in this bluish color, which means that they are secured over TLS. So now what I'm going to do, I'm going to connect another application to this Zeno infrastructure, and we are going to see something pop up in the US router. So I've seen something that pop up to this router, and in particular, if we go to look at the legend is a client application. In this case, is an application that is on my phone. That's
an Android application.
An Android application, and I want to share actually the screen of the Android application. So just let me do something very quick.
We can also show on the camera here.
Yes.
That's
while I open the. Julia, can you approve on my laptop?
The screen sharing.
Yes.
Yeah. So there are multiple.
I need
Just
to
to
put
make
the
things
finger.
a little bit more complicated while being live.
Yes.
We just,
I mean, it's just because.
Okay. Otherwise, it's too easy. If it's too easy, it's no fun.
I mean, it has to be the demo effect. So.
I mean, it has to be a miracle each time it works, which is great, right?
Okay, so now
allow again. You need to allow. Yeah.
No, I don't. Okay. Just to say,
yeah.
got it, and I need. Okay, it's fine. We can see my phone. So this is the application on my phone. Yes, but you will move just one robot.
I'm moving one robot.
You're moving one robot.
Yes.
So let me just put this again, and I want the airbeads. So we are moving one robot, and we can see actually the LiDAR is moving.
Going to crash it on Julian Fit.
Okay. And then we are going to move also the other both robots at the same time. Yeah. So this is actually quite similar to the demo that Julian did, but in this case, instead of everything locally, we are driving from my phone that, as we can see from the graph, is connected to the US router. Actually, if we connect to the US router, it will tell us that there is something connected. So see, there is something connected.
I keep chasing Julian.
Yes, there is a client connected to him. So it's from my phone going to North Virginia, going to Frankfurt, going to the local router, going to the robot. And as you can see, we are driving quite well without that much latency, although we are going through the internet. Where you are going?
It was going toward the wine. I think it's
okay.
I don't know why, but the robot is going toward the wine.
We can also control both of them.
It is an intelligent robot, apparently.
If you can bring it closer, we can control.
Let's bring it
and as you can see, the data is also still locally, which means, for instance, in this case, I'm not subscribing to any data from the camera, but you can still see that the camera is being sent through Zeno. This is, say, usual Zeno magic. Okay.
Coming back on.
Okay. So
you can also drive.
Yeah, no, I want to control both robots because just one, it's easy. So let's just. I'm changing the declaration for my publications, and now if everything went well, yes, I'm driving the two robots at the same time.
Yeah, but now we can only see one from the. Yes,
we can see both.
Yeah, we can see both. Yes.
So let's try to make them
closer.
Closer. It will be a bit difficult, but we will manage.
Yeah.
And of course, for this, I can change the speed. So, for instance, try this. I mean, I'm sending directly, in this case, CDR encoded data from my phone, which is a Zeno application. So you're showing also the Kotlin API for Android.
Yeah.
We are driving the robots going through the cloud. So it's not the best, let's say, way to drive them, given all the round trip that they are doing, but it's actually to show that with Zeno you can get very low latency even going through the internet. And of course, now we say that in the ROS2 bridge for DDS, there is the Zeno bridge for ROS2, there is the support for the action. So I can tell the robot, please go home. And I think they will not be easy for them to find the.
We'll see. To dock.
One manage maybe.
Let's see.
And so the dock is actually an action in ROS2. So well, now this is the Roomba algorithm that is kicking in. So everyone that has a Roomba knows that sometimes it's difficult to find. I think it stopped because it is okay.
Yeah, I think they're a little bit confused.
Yeah, we can drive them there. Let me drive bot one first. A bit faster, please.
Should be good here.
So please go home. Well, they find the first one. As long as they find one, okay. So did manage. Do the same thing with bot 2.
Yeah, I think I found it. Yes, nice. Okay, good. Docked.
Let's go dock also the other one. I mean, they worked a lot today. They had a demo to do. So let's chart them. And I'm driving them actually looking at the screen. So I think it's enough, right? Yes.
Yeah.
Sorry.
For it.
We'll manage eventually.
No, that doesn't want to dock.
It doesn't want to dock. It wants to party, this robot. So it's doing, I don't know, maybe we'll find it.
There it is.
Mine needs to align itself.
Yes. Okay, yes.
Eventually. No.
I think the second dock is too close.
Yeah.
That causes troubles.
Okay, let's move forward.
Let's move forward.
Okay, good. Thank you very much, Gabriel.
You're welcome.
Anything else?
I mean, you can just see, or for instance, you can update a project if you want. So in this case, I've seen a project that is already there. What if I want to see actually the applications that I connected to this project, the clients that I generated? We can also see them, and we can also expect the configuration that is generated automatically.
Good.
So we can also download it again if we need it, or we can, as I say, everything is simplified. So if I say, I want to use my project, okay, I want to connect what? For instance, a client application. It's most of the case. I already have 2 client applications, so it's telling me, are you sure you want to connect another one, or you want just to use the one that you already created? So now I want to create a new one. Let's call it my app. French keyboard. Yes.
Ready?
Yes, my app. So I said I can decide to which router connect it. So for instance, let's say I want an application connect to the US router. We'll just click next, and I will get a link. And this link, I will have everything that is needed for me to run the application. So if actually I want to do it quite quickly. So let's just copy it, just unzip it. Actually, let's say, okay, I copy to the clipboard, click next. It tells us also, for instance, how to run the simple example of Zeno. So if we want to, we just downloaded the configuration. If we want to try it, we can either use the examples, and we'll tell us how to download a publisher, and then we guide us to the documentation. But actually, let's see what there is in the zip my app. So as you can see, it has inflated few files, and so you can see there is two free file for security. So we have the root certificate for this project, the client certificate, and the client key. And there is a README in which there is instruction how to run it, and there is a configuration file which contains the Zeno configuration. So if we look at the README, so in the README there is all the information that you need in order to run this application. It tells you, okay, this archive contains the configuration of Zeno, the root certificate for this project, the client key and the client certificate for this application, and how to test it and how to run it. So that is actually just a few clicks and you have your application running.
And the platform is available. It's, by the way, cheaper than your average MQTT platform.
It's cheaper than your average MQTT platform. And you get also 500 gigabytes of data included.
And all the traffic that you route locally
is
for free.
Yes,
right.
So if you just create route and everything stays local, you don't pay the traffic that goes through. So
great.
Thank you very much. I'm going to look for questions if there is.
Yeah. So look online, and so thank you. So lots of flow today. So let's continue with the flow. So Julien Laudet. How about we give the latest update on ZenoFlow? Should I check to see if? Let me double check.
Luca is presenting on his laptop and there.
Okay, great, perfect. So here we go. So before we do that, you ready to go?
Yeah, I'm ready to go.
And you are on stage.
No.
You are.
Yeah, but is it? No, it's not.
Go again. Show again. You are.
Yes. I wanted to hide this.
Yes, just click it.
Yeah, that's what I did, and then.
No, and then you should, if you do it again, do again presentation mode, it should be gone.
Yes, awesome.
The floor is yours.
So, just similar to the presentations that were given by our users, concluding with ZenoFlow, let's conclude this Zeno user meeting with a short presentation about ZenoFlow. So my name is Julien Houdet, and I'm the project lead for ZenoFlow. So first, we didn't make a lot of noise about ZenoFlow, so let's give kind of a genesis. So where did we start with ZenoFlow? So we basically were contacted by a customer that asked us to create a distributed data flow programming framework based on Zeno. The idea was to emulate this project that is developed by the University of Berkeley called Pilot. And our purpose was to replace the underlying data flow programming framework with ZenoFlow. Luckily, everything went well, and this is a simulation that we run. Yeah, where basically this is exactly the same logic. We just kept all the nodes, all the logic, just replaced everything with ZenoFlow to check that it was working. So our first approach with better performance. So our first approach was successful. When we mean better performance, the main difference compared to their solution is that we didn't need to stop the simulator between every frame. So the Kala simulator sends us a frame. We are able to compute the steering and acceleration or braking that we need to give the simulator. And then by the time we send its information, it has time to send us the second frame and ever going. Obviously, this was not running the full machine learning pipeline, just the perfect perception. How is the deployment? So to deploy this ZenoFlow application, what we did is that downstairs in our servers, we have one virtual machine that is running the Kala engine simulator, and we had another virtual machine with the ZenoFlow, so everything, the ZenoFlow runtime. And basically, there was publishing and subscribing through Zeno in order to send the information. So this is how ZenoFlow started. So after this first project, what are our motivation for ZenoFlow? So the first is, well, we already have today a distributed declarative data flow framework that gives you full control over the flow of your data. This flow, we strongly enforce it and work seamlessly on a single or multiple hosts. So this is the first basis. Then our motivation also is that, much like Zeno, but this is even stronger for ZenoFlow, this is developed in Rust. So why Rust is important nowadays? Well, we're seeing many traction, especially in the automotive industry, to use a programming language that is memory safe, concurrency safe. We can see also that we have now the Ferrocene that released the first Rust compiler that is certified for ISO 26262. We also have testimonies from, for instance, Volvo engineers that think that Rust is actually a good idea for your car. Or lately, and it's created a little bit of buzz in the Rust community, the CTO of Microsoft Azure that says that for new development, it's time to use Rust instead of C and C++. So with these things going, we are also seeing that for autonomous driving applications nowadays, ROS is considered as the default, but it has some limitations. This is perfectly illustrated from a talk that the guys for working at Cruise, so a subsidiary of General Motors, showed that they need to have a precise computation graph, which is something that ZenoFlow already offers. Then we need also to schedule this computation deterministically. And if you recall the presentation from Christopher, this is something that we're aiming with ZenoFlow. So with this, we're also seeing that AutoSAR Classic and Adaptive are a bit heavy. Again, I relate to Christopher's presentation that the developer experience is quite poor, offers little flexibility, and to recall, again, my point on Rust is only in C, C++. So with all of that, we're thinking of future perspectives for ZenoFlow. The first is the ongoing work that we're doing with TTTech, which is the custom scheduling. What you can see on the screen is the Rust real-time AutoWare reference system. So what we did is that we enhance our descriptor, so the way we're describing our data flow, in order to provide users the capability to schedule, to say which nodes should execute next. So this is something that we are going to provide in the beginning of 2024, is the ability for users to specify how they want to schedule their computation based on the graph. We're having some preliminary results. So what we did is that we emulated workload on each the node. So what you can see in the small rectangles are the computation time we associated to each node. And we ran that on a Raspberry Pi 4. And so what we can see is that we have on a single core a theoretical lowest execution time of 12 milliseconds. You can recompute if you don't trust my numbers, but after running this simulation using ZenoFlow and our guided execution, we see that our execution time on average on a single core is 14 milliseconds, which is quite close to what we can achieve in theory, meaning that the overhead of ZenoFlow is minimal. I have some numbers in my mind, so I would put a grain of salt on them, but I think running the same experiment that TT Tech did using ROS and also using their optimized scheduling algorithm, they reached 60 milliseconds. So we can already see that we're having quite few improvements just by changing the framework. This is great, but we want to go a step further, and we want to provide real-time capabilities. So these real-time capabilities are motivated by the requirements coming from the automotive industry. The first is the ability to park a task. So when we say park is, again, as Christopher explained, if we associate a time budget to a computational node, and then that node overruns that budget, we want to not kill it, but we want to park it on a specific thread that we will run whenever we have free time on the CPU. We also want to assign priorities to tasks. The idea is that depending on your environment, maybe there are some tasks that have a higher priority and you want to execute them first. So ZenoFlow will provide a way to do that dynamically. Third point is we want to be able to pin a task to a specific CPU core. Depending on your requirements, depending on where you are, maybe you want to reserve one specific CPU core to one task in order to guarantee safety. Lastly, and because we are called ZenoFlow, we also want to integrate with an automotive middleware. Well, this is already done. Zeno is already in the automotive stack. It integrates very well with Zeno DDS, so it means we already have a step in there. And with this, I conclude my presentation on ZenoFlow. So expect to see this, obviously, beginning of 2024. And ZenoFlow, much like Zeno, is an open source soft initiative. So we're welcoming any contribution.
Okay, thank you very much, Julien. Thank you to all the speakers, and thank you to all of you who resisted to this online Zeno marathon, because it was an epic marathon. We'll still, hang around here to enjoy some refreshments and keep answering questions asynchronously online. So thank you again for the team. Thank you again for the attendees here. Thank you for the attendees online. And, see you online. Bye, everyone. Yeah, thank you. Okay, guys, I'm stopping.